Right, I'd like to welcome you all here to the session this morning. For those of you who don't know me, my name is Prof. Jeff Smithers. I'm currently appointed as UMNGENI UTHUKELA Chair of Water Resources Research and Innovation at UKZN. I'm also the Director of the Centre for Water Resources Research at UKZN. So I'd like to welcome you to this third session that we've had for UMNGENI Water. So we started this a couple of years ago, and we'll have a look at why we're doing that a little bit later. I know we've got some very high-powered people in the audience, so I'm just going to say all protocols are observed, and you're all very welcome. Right, just a bit of background. There is an MOU between UKZN and UMNGENI UTHUKELA Water, established in 2010, that was recently renewed in 2021. And really the aim there is to establish mutually beneficial projects in teaching, research and technical services, and to establish an endowed professorial chair at UKZN. Right, so this chair has been running since 2010, recently again renewed in 2021 for a 10-year period, so we're very grateful to UMNGENI UTHUKELA Water for that. And that provides funding to support the chair as well as postdoctoral students, as we'll be hearing from today. Right, my understanding of these MOUs and memorandum of agreement between UMNGENI and the university is really national capacity development, conduct research in fields of water resources and related fields, and I think critically to try and promote closer collaboration between UMNGENI UTHUKELA Water Board and the university. To me, it's a win-win situation. You've got an industry that has research needs. We've got academics looking to do real world and make an impact on society. So the closer we can work together makes a lot of sense, in my opinion. So really, part of my job is to try and encourage researchers at UKZN to focus on issues that are related and applicable to the Water Board. To go back, so in addition to funding the chair, there is significant student funding that is provided, and you can see the numbers there. Something like 39 students have been funded and have graduated. Also, the bursaries, more than 6 million rand in bursaries have been paid since 2021. And then there also are specific projects that UMNGENI undertakes with specific disciplines or groupings within UKZN that they also fund. Right, so the intention of today is really to provide feedback to UMNGENI UTHUKELA Water on some of the activities that they have been funding, and also just to promote collaboration between industry and researchers. We want to create awareness on both sides of what the needs are and what the capacity is, so we can try and utilize those and collaborate on research. We want to break down some of the silos that we find ourselves in. Quite often we don't interact enough, so that'll be good to do that. And then also try and promote some multi-discipline work and collaboration where possible. Right, so that's the program. I'm not going to go through that in any detail. We've got quite a few presentations to get through. So our first presentation is going to be done by a keynote speaker. I guess for those of you who were here last night, we know who that is. So it's Dr. Ntsapo Depa. She's the Chief Executive for Scientific Services at UMNGENI UTHUKELA Water. Again, I think I'm just going to briefly look at her CV. She holds a PhD from the University of Cape Town in chemistry. She also has an MBA from the University of KwaZulu-Natal, cum laude. That's excellent. She has worked in various roles, from working at the Vaal University of Technology. She's also been a manager at Tongaat Hewlett for 9 years. So without further ado, Dr. Depa, I'd like to hand the floor over to you. And we look forward to your presentation, which I believe is going to be advancing and inspiring industrial research and innovation through research and innovation chairs. Thank you very much.
All right. Just some background as a reminder from yesterday on the role of UMNGENI UTHUKELA Water within the water value chain. that the organization is part of the Department of Water and Sanitation, and we abstract water from the rivers and the dams as raw and as polluted as it is, and we treat it to the desired SANS 241 potable standards, and we sell that water to the municipalities. The municipalities then distribute it to the households and industries as well. Also, we do sanitation services for some municipalities, mainly Herigwala District Municipality and eThekwini municipality as well. So this is where we actually fit in within the water cycle as UMNGENI UTHUKELA water. And the reason why I'm highlighting it, this water cycle value chain is that UMNGENI UTHUKELA Water's corporate strategic focus area is actually looking at 3 themes. And one of those is operational excellence, where we're looking at delivering water services of the required quality and quantity within acceptable levels of potability. And this is where our SANS 241 standard comes in, and our legislated wastewater standards come in as well. The second one, which is as crucial for today, is research, development, and innovation. And as the organization, we are investing in new systems, tools, technologies, and methodologies to support a continuous improvement culture that delivers relevant products and services, which in turn create value and growth for our customers and stakeholders. And these are the strategic areas that the organization lives by. And in addition to that, there's been like a whole talk as of yesterday about strategic collaborations and partnerships. This is exactly what we are all about. And even today's session is exactly all about where we want to be establishing strategic collaborations and partnerships. And we are identifying all these relevant strategic partners. And as you've heard, I don't know how many times it's been echoed, that we established this relationship like a way long time ago, as back as 2011. So it's those 3 strategic areas that are well fitting for this session as well. And where do we actually come in all this in terms of like research, development, and innovation as well? So as these 3 themes like research, development, and innovation, we definitely had to respond to the 3 focus strategic areas of the organization as well. And in so doing, we then developed the research and development master plan and the research, development, technology, and innovation strategy. And within those 2 documents, we identified 6 focus areas that encompass the whole value chain. And the first one is on improvement of the water resources management. You will be hearing in these presentations that we'll be focusing a lot on initiatives that are addressing water resources management. And the second one is improvement of environmental and pollution management. We're having talks in this area as well. The third one, obviously, for us to get to the desired quality standards for potable and wastewater, we need to be looking at technologies that advance the optimization of water and wastewater treatment. And obviously, we operate a whole lot of infrastructure, very billions actually of infrastructure. So we have to be looking at technologies and innovation that actually focuses on the enhancement of the infrastructure development and management. Also, we generate a lot of data from not just water quality monitoring in various areas of our operations as well. So the fifth focus area, as far as research and innovation is concerned, is the enhancement of business processes and data management. And lastly, the buzz even for this conference is energy efficiency and sustainability. So these are the 6 focus areas that our research and development are actually delving into. Moving on, just to highlight exactly what the strategic objectives are for each of these. For the water resources management one, we're looking at ensuring that we use research, technology, and innovation for protection, efficient use, and conservation of our water resources. And there's a lot of pollution that's going on. You would have had in the past few weeks with the water supply challenges to eThekwini municipality, which were actually due to the pollution that was upstream, one of the major dams, Albert Falls, which is the biggest, which forms part of the biggest system for the Durban Heights water treatment works. And we have to be intentional and deliberate in ensuring that we have ways of managing and controlling pollution through innovation and technology inventions as well. Advancing our water and wastewater treatment processes, we have an objective of ensuring that we use advanced technologies and innovation by all means. So this is where innovative ideas need to be coming in. And Jeff, I would like to highlight that and challenge the team that looking at these 6 focus areas, we just need to ensure that the research that we undertake is not just desktop research, it's research that's advancing and addressing all these challenges that we are having within the organization. So ours, yes, it is knowledge management and capacity development, but our research needs to ensure that it optimizes our existing business processes, it improves our operational efficiency, it enhances sustainability of the organization. It also reduces our operational and treatment costs, and in so doing, reducing the turnaround times. So it must be all about addressing existing challenges. We are being challenged by the board in terms of like how we are undertaking research to ensure that we are establishing a return on the investment that we are putting into the research initiatives. Yes, of course, our return on investment does not necessarily have to be monetary, but if it addresses these key areas, then we are spot on. And we need to be providing evidence that indeed, from whatever initiative that we are undertaking, we have proof or evidence of optimization of operational challenges, reduction of turnaround times. So hence, I'm actually emphasizing that it cannot be just a desktop research. It must address the business needs at all costs. And as we were looking into this, obviously, UMNGENI UTHUKELA water is more about operations and treating water, selling it to the municipalities, our main customers. We don't have research expertise whatsoever. And this is exactly where the UKZN chair comes in. Yes, we are focusing more on UKZN as of today, but we do have other collaborations with other universities as well. But the strongest that we have is with UKZN. And it's through this chair that we are advancing our research and innovation initiatives. And you've had quite a number of times that it was well established as far back as 2011. And it was just for a 10-year tenure. And had we not borne fruits out of it, we would not have extended it any further. And it's quite crucial that it's mainly because of the outcomes and outputs that we got out of the chair, that when that tenure came to an end, we were like, why not? Because we're benefiting so much out of this. And the good thing of this is that the initiatives that are being undertaken as part of the chair are overseen by project managers within the organization. So there's that track of progress and ensuring that there's implementation thereof, which will then translate into this return of investment that we are looking for at the end of the day after all these initiatives are being implemented. So it is very crucial. And we do have quite a number of initiatives, and I just wanted to highlight the multidisciplinarity of the chair because, yes, we are science and engineering, and the theme for this piece is science and engineering. But we're looking at water resource planning and management, environmental pollution and management. This, of course, is addressing these focus areas that I've highlighted earlier on. We're looking at biodiversity management. We're looking at all these other disciplines of engineering, electrical, down to civil as well. We're looking at climate change management, big data informatics, as well as capacity development. I must highlight that, yes, capacity development is crucial, but to be frank with you, it is secondary to us. What is key is addressing existing business challenges. And this is exactly where our strength has been. This is what we've actually ripped out of this implementation of the chair. So it explains how crucial it is for us. Am I also being timed? How crucial it is that we are advancing this research through this chair. And there's a big opportunity, obviously, to expand it even beyond this current tenure, Jeff, I must highlight. But obviously, there are certain areas where we also need to be improving on. We're not as strong in terms of like waste management. Through the chair, Jeff, we do need to be considering that as well. We're not as strong on big data informatives. we need to be improving on that. And what's even more crucial and also highlighted yesterday, energy efficiency and management. I was quite thrilled to hear the talk by the keynote speaker at the gala dinner yesterday, that there are certain strides that have been made as far as energy management and efficiency are concerned. So it's another area that we really need to be stepping into. So it's just a challenge that I'm posing to you, Jeff, that these three other areas need to be considered as well as we work on the balance of this tenure as well as more tenures to come. You've had it all in terms of how far we've come with the chair as far as 2011 up to 2021, with the previous one being Prof. Jewett, and before he even concluded his tenure, he had to relocate, and we had Jeff taking over from 2019, and he's been doing a very sterling job. Hence, when that came to an end, the first term came to an end, when we then renewed the contract, we still had Jeff on board as well. And in terms of the deliveries that we've had, we've already had 76 publications coming out of this chair. We've had 5 postdocs. I must highlight that we also initiated a postdoc venture as part of the chair because it was mainly focusing on honors, masters, and PhDs when it was implemented. But we identified a need for postdocs as well. Yes, because it was a new territory, there were certain glitches here and there, but we are resurrecting that initiative once again. So this is just to cement that with everything that has been unfolding with the chair, the sterling work that has been done, we are quite pleased, Jeff, and we are quite pleased with UKZN in terms of advancing and inspiring our research as UMNGENI UTHUKELA Water. So well done, and we will continue with this relationship. And this is the only way that as the organization will be in a position to achieve those 3 strategic focus areas on operational excellence, research, development, and innovation, as well as enhancing our strategic collaborations. Thank you very much. Good luck to all the presenters who will be showcasing their research and innovation initiatives to the UMNGENI UTHUKELA Water staff today. I'm sure they will be quite pleased. Thank you so much.
Thank you very much, Dr. Depper, for those encouraging words and some challenges. We're certainly aware of them. So that is something that we are working on, but I think we need some more discussion about that as well. I'd like to open the floor to any questions, both in the venue as well as online. So if you can just keep an eye open online if anybody wants to put their hand up. Maybe if I can just kick off, Dr. Depper, and again, we could probably spend a whole day speaking about this, but how do we promote, I guess, what we've started? How do we grow it more? We've spoken about this collaboration and the potential that there is, but how do we do it better? And how do we get more project managers at UMNGENI involved, as well as researchers at UKZN involved? It's certainly something that I spend a lot of time thinking about. And I know we're all very busy, and just getting people at both organizations to commit to work together. As I said, to me, it just seems like a total no-brainer that we want more collaboration, but sometimes it doesn't always flow so easily. And off the top of your head, any suggestions that you could think of?
I think, Jeff, we really need to be intentional about it. I must highlight that we've had some challenges, honestly, and it is indeed an area that we need to be improving on. And I think as much as it appears to be a challenge with the project managers, but I think it's more a challenge with coordination. You know, how do you bring these project managers together? Who's actually leading all that? So I think that's where the problem is, honestly, and it is a challenge that we are looking into because that person has to be the go-to person to the chair. So perhaps even the project managers are facing a challenge as to how do we then get hold of the UKZN chair? How do we advance our needs to the UKZN chair? So it is a shortfall that we are working on within the organization, and I hope that it's gonna get to improve with time. I do understand exactly where you're coming from.
Thank you very much. Are there any further questions? Nobody online? And I think, just to wrap up, we have had some good examples, I think, for example, between UMNGENI Water and the Wash Centre. I think that has worked, so we need to learn what worked there and try and replicate that in other fields within UKZN. So thank you very much. Maybe just before I call on the next speaker, I'd just like you to hand over a gift of our appreciation again for your keynote speech. So I think you're collecting quite a few things to take back with you after the session today. For a team to eat. Yeah, thanks, great. I like that. Yeah. Okay, we're now going to move into our student presentations. So that's really what today is about. We're wanting them to present what they're doing and interact with industry and to take feedback. We certainly appreciate that. We have got a couple of presentations that are going to be done online, and I guess for connectivity problems, we did ask them to present, to prepare video clips just to make sure we don't have connectivity breaks, but they are going to be online. So our first presenter is an online presentation. It is supposed to be a video clip. Yeah. I think, is this the video? No? Okay, all right, thank you. So the first presentation is Sandile Dladla, Enhancing Flood Risk Assessment Through Multivariate Frequency Analysis, a South African Perspective. So Sandile is online to answer questions after the session, so can you please play the clip?
I will firstly use the term that was used by Andrew Goggins in 2007 when he was developing the joint peak volume methodology, where he said that the South African design practice operates in a comfort zone. By that he meant that the design flood practice is only directed or is focused on one flood variable, and then it's either the peak in most cases or the volume, and the assumption is that either one of the two, we assume that the assumption is that they are from the same probability of accidents and also the same probability distribution, and they predominantly focus on the peak flows. As I've also mentioned earlier on, is that it's only appropriate in some hydraulic designs. And the other criteria is that some of the design event models are unable to reflect a real-world variability. This was reported by UUW Maharaj in his WRC report when he looked at the SCS model being unable to reflect real world variability, where if you had large peaks, they were not associated with high peak flows, and if you have peak flows, also not giving you very good estimates of volumes. The last fact about the design flood estimation is that the joint probability models, which are your joint peak volume or JPV and the Rhine hydrograph, have not really gained widespread adoption in South Africa as far. So, and then we look at the aims of the project. We're looking to use coupler functions to model the dependency between the flood variables, which are your peak discharge, flood volume, and also incorporate volume in the process. And the other aim is to develop a procedure for performing a multivariate regional frequency analysis using these coupler models. So this graph is a typical design flood hydrograph, which then the dilemma for engineers when they're doing design is that you have your peak flow, your flood volume, your flood durations, and your inflection points, and then that's your complete hydrograph. But the challenge is, if it's only focused on the peak flow, there are multiple volumes which can result from that peak flow. For example, you can have a large peak flow, which is similar to the one from the first graph, but with a small volume and a small duration, of which in some cases it's really not as does not have an impact on your structural failure or structural design that much. But in some cases you have low peak flows with large volumes and large and long duration, which has been reported to have major impacts on your structural design and structural failure. So of which in most cases, if the flood estimation is focused on the peak flow, you are most likely to miss this flood event. So the starting point for the project was looking at these methodologies which have not gained widespread adoption, to see why exactly practitioners not using these models. For example, the joint probability model, the joint peak volume methodology, it is based on empirical relationship between peaks and flood volumes. And then Andrew Goggins used excellent percentiles of standardized volumes, and then were conditional on the standardized peaks, which were derived through pooling groups, which are your fail type zones reported in the HRU 1972, your K regions also reported by Kovacs in 1998. From these accident percentiles, Goggins then developed relationships between the two, which were then found to be linear, and then resulted in a linear methodology for the JPV methodology. So you also included regional pooling approaches for ungauged catchments, where you are given a peak, you can estimate the volume for any given return interval. This was achieved through pooling strategies. Firstly, looking at wide pooling, where you're looking at large-scale pooling groups of catchments, and narrow pooling, where you're looking at localized hydraulic similar catchments in the vicinity. So the basis for this methodology was that you have your standardized volumes, which are conditional on your flood peaks. And then you look at the relationship between the two. So in this case, if you look at the graph on the left, you have the relationships or the combinations of volumes and peaks. Then Andrew Goggins then developed the trend line equations from these equations, looking at the 58th percentiles, 25th percentiles, and the 5th percentiles. From that, if you can then derive, if you have one value, you can then derive the other using these trend line equations. So, but the challenge with that is that one peak value does not result from a single volume, or one volume also results from multiple peaks. So which one do you choose? And then which is then an answer that is not answered correctly, or is not clear in this methodology at this point. So the first start, or the pilot study, was looking at the Cathedral Peak catchment, which is a well-maintained catchment thus far, for instance, and then for the past few years, and it has some very good streamflow data and rainfall data sets. So the first was looking at the CP6, which is one of the Cathedral Peak catchments in this vicinity. Then looking at the relationship between the volume and the peaks from the observed data set, I realized, or I noted, that the relationship is very is not that strong. So meaning, what does this mean is that if you have either of the two, you cannot then extrapolate using the equation that you can see from there to get the volume. You're not going to get a very good estimation of the two. So I then went on to look at the relationships into depth, what is happening between these two variables. Firstly, if you look at, we have a very big volume, or a very big event, peak event, and then you will assume that this peak event will also be associated with a big volume. Then, which in this case it was not the case. And then you assume that you also have a very big event in terms of volume, which is not clear, or is not clearly visible on the peak. So you can see from these two that there isn't a very good relationship between your peak events and your flat volume events. From there, I went on to check the probability distribution analysis of these two flat variables. I noted that the flat volume fits much better on the general extreme value distributions, and the peak flows also fits much better on the LP3. You will recall that I mentioned earlier on that the assumption is that they are both from the same distribution. And then went on to do some statistical analysis. The most importantly is the correlation from this table here, which is then shows that it's less than 50, 0.5%, and the p-value is also less than 0.05%, which means that between these two, it was very significant. I then went on to modify the plotting position formula to look at a joint empirical probability of these two variables, where it's now from the ranked value is now replaced with NMI, which is the combination of the peak and volume located in a two-dimensional plane. Then from that, I apply these two models, which is the mixed Gambian and logistic models, which are mostly used in other countries, in America and France, Spain, and some other countries. So I apply these two models to try and characterize the theoretical probability distribution. From there, I obtained a relationship between theoretical joint non-exceedance probability and empirical probability, and then I found that there's a very good correlation between these two, but the criteria is that these two, they should have a one-to-one line. For instance, you look at the graph on the left, it is very close, but if you then go to the graph on the right, it shows that if you have your extreme values are becoming bigger and bigger, the separation between these two graphs is becoming also bigger, meaning that for your bigger events, it's not going to give you very good estimates of either your flat volume or your flat peak. From that, and then which then brought me to the theory of copulas, which and then I look at tail dependency, which of these methods or methodologies or models can represent the tail dependency of the data sets between the two. I then found the copula models, and which means that if you have two or more variables, you can model these two variables using a certain copula function, which is then dependent on your data set. And then you can see the equation 1.5. You have f of x and f of y, which is your univariate marginal distributions. The good thing about these marginal distributions can be of the different family as well. So, and if you continue, in case of the good thing about copula functions, that in a univariate case, you have your relationship between return period and your flood frequency and your frequency estimates, which is represented by a linear line. But in the multivariate risk analysis, a given return period is associated with a set of events instead of only one, and then from that you get a joint return period curve, as you can see from the left hand side there. So the also good thing about that, it also allows for a conditional return period, which is based on these two conditions here. For primary return period, you have your random variable x or y is exceeded, one of the two is exceeded, and then the secondary return period, which is you have both your variables x and y as exceeded as well. So, and then from that you can then develop these return period curves, and then you have your variables x and y can be your volume and peak, and then dependent on your return period you can use either of the two. If you have a volume, you can extrapolate and get a certain peak which is dependent on your return period. So lastly, the idea is to move or to force practitioners to move away from the linearity of thinking that as one peak value is also a resultant of one peak volume, and then the peak discharge values, which from the univariance, is also associated with a certain return period, of which also the volume resultant from that is also of the same return period. So we want to do away with the univariance and pass the multivariate frequency analysis. I'm still going to go further into this. I have not arrived yet, but it's a very promising model which I'm very interested to see the results from. Thank you very much.
Thank you very much, Sandile. I don't know if we can just show the people, the online people. Thanks very much. I'd like to open the floor to questions. So that was a very interesting presentation. I know it is fairly mathematical, but really what we're doing, we're trying to push the boundaries with some innovation for designers out in practice, and to really acknowledge the uncertainty that we have when we're making these estimates. And we'd like practitioners to also do that work as well, or to implement that when they're designing structures in practice. Any questions from the audience or from online? Okay, so you can see it's part of a PhD study. It's still ongoing. Maybe, Damien, if you can, maybe it's a quick question from me. Have you given any thoughts about how you think practitioners would be able to utilize this once you finish your study? Do you think you'd be able to get them to adopt something, this joint probability approach in practice?
Hello, Prof. Can you hear me?
We can hear you. Please go ahead.
Prof, I guess we could, Prof, because yesterday I was just reading in some of the responses. I think it's one of the reports that you presented to WRC and SunCold, and then in that report, the practitioners were concerned about some of the models, and in one of those, they also asked that we look at the JPV methodology and then we try and render it into a probabilistic model, as it is not in this case, which is, I think, for me, it's an interest that they also want to see the models improved. I think maybe at some point, I know at this moment it's just a mathematical modeling issue, but at some point we're going to have to try and make it easier for practitioners to adopt, because at the moment it's completely very complex. But I think it's going to be an ongoing study to try and make it easier for practitioners to adopt, I think.
Thank you very much. One last question.
Thanks, Sandile.
I just want to check, are you having any engagements with Futhi Vilakazi from UMNGENI UTHUKELA Water? And the reason why I'm asking is she is looking at some models, and one of those is HydroNet. And in relation to Jeff's question, and as I mentioned earlier on, that perhaps you should consider that what you're doing is going to be eventually implemented within the organization. So it's well and good that yours is at early stages. I think we do need to engage with Futhi on how we can actually enhance your project so that it becomes applicable to UMNGENI UTHUKELA Water. And as we do so, we look at the existing flood-focused initiatives and identify exactly how we can incorporate your one to further enhance the existing ones that are being looked at within UMNGENI UTHUKELA Water. So it's a challenge that I'm actually going to pose to you to ensure applicability of this model within the organization. Thank you.
Thank you very much, Doc. I know Futhi, but we have not really spoke. I think since the last time we were in class together. But I'm gonna try and contact her because I do have means to contact her and then see how can she be of assistance in this project. Thank you very much for the suggestion.
Thanks very much. Yes, certainly connecting with Futhi I think is good. But maybe also others at UMNGENI, maybe even Kevin Meyer, uncertainty in water resource planning. I think there are aspects that we could pick up there as well. Thanks. So thanks very much, Sandile.
Thank you, Prof.
I'd now like to move on to the next presentation, which is going to be done by Damian Mukansi. And the topic of his presentation is going to be detecting trends in rainfall and flood extremes and non-stationary design flood estimation in KwaZulu-Natal. Over to you, Damian.
Thank you very much, Prof. Good morning, everyone. As already introduced, my name is Damian Mukansi. I'm a PhD student at the University of KwaZulu-Natal. I think, firstly, I would like to take this opportunity and just appreciate UMNGENI UTHUKELA through the research chair for the funding, which enables us to do our research. This morning, I'm going to present on detecting trends in hydrological extremes and incorporation of non-stationary models in design flood estimation in South Africa. Already Sandile had already started speaking about design floods, but maybe I'll start off and just briefly define what design flood estimates are for the benefits of everyone in the audience. So it's really a design value which has a magnitude with an associated level of risk, and we characterize this level of risk using what we call a return period. So detecting trends in hydrological extremes is important for the design of hydrologic structures such as dams, spillways, and culverts. However, the current methods which are used in design flood estimation, more especially in South Africa, assume that your hydrological cycle remains stationary. By this, it assumes that the parameters of your probability distribution functions, known as PDFs, are stationary and do not change with time. So it assumes that the mean, the standard deviation of your data does not change with time. However, there are several studies that have shown both an increase in magnitude and a frequency of extreme events, such that as opposed to just having this, I'm not sure, maybe it's the battery, it's fine, just having this one linear graph where you have a peak with its associated return period. There are several studies that have shown that you have an increase in the magnitude of the return period to a point where Okay, let's try this to a point where if you, for instance, if I make an example with the 40, sorry for the guys that are online that cannot track what I'm doing, but if you look at the 40-year magnitude, in terms of the old one, it remains constant, but there are several studies that have shown that in terms of the 40-year, you can see there that if you look at it, its return period is now lesser than it is here. So this shows that in terms of the same magnitude, there are chances that it's happening more frequent. And so a big event that had a higher return period in the past could now potentially have a small return period such that those big events could be happening more frequently. Likewise, the other part is also true where you have a reduction. And so this has caused an increase in studies that are focusing on non-stationarity and just not assuming that your data remains stationary. The rationale of this study, I'm just going to make an example. I extracted just Sanral for the purposes of this presentation, but the same can be said about SunCold when it comes to the design of dams. So as most people can know, SANRAL is the highest regulatory body in South Africa in terms of designs of all major roads in the country. But in its current form, the methods which it prescribes existing design flood estimation methods which assume that your hydrological cycle is stationary. A study by Miyambo in 2022 reported that inadequate design of drainage structures has resulted in flooding of the N12 in Johannesburg. So this is just a show to say that if we are not going to design these drainage structures adequately, chances are they're going to fail. And for design, your design is as good as the assumptions that you have made into the design. And so currently the assumption that we are making, I'm still trying to emphasize, is that we assume that your hydrological cycle remains stationary. One of the rationale for the problem is you can already see there. I'm just going to zoom in only to the 2022 flood event, which I think most of us can relate with, the one that happened here around April. The damages of that event, close to 17 billion. The people that lost their lives during that period, 435 people. That's a family, probably without a dad, without a child, a breadwinner. So you can already imagine that at a socio-economic level, if we're not focusing a lot on the floods, it has got a potential big effect in terms, not just at a small scale at family level, but also even for planning for the country as a whole. So the aim of the study is to determine trends in peak discharge data in South Africa, and number two, to incorporate non-stationary design flood estimation in South Africa. We are students, majority of us are from UKZN, and you can see there that even UKZN itself was not immune in some of these flood events, where you can see that our vehicle was caught wanting in these events. So the preliminary data which I'm going to present, where most of the work that was done is along the east coast of KwaZulu-Natal, which also covers bulk of UMNGENI catchment. The methodology that is used for this study, the first part of the study is collection of flow data, and you can see that I have now written and rainfall data, but that's because we did the studies in phases. The first part is we looked at what has been happening to the stream flow, and you'll see as I conclude, when we found that the stream flow was showing negative trends, the first questions that everybody rightfully had was, maybe it's not climate change, maybe it's just obstructions upstream, which are now being picked up at your gauging station. And so we then decided to say, then let's look at rainfall, which has got no obstruction, which you can't make the same argument, to see what has been happening to the trends there. The second part is that we screen the data using the data quality as well as the record length. So in terms of record length, we were looking for a record length of over 40 years, and in terms of data quality, if you had more than 10% of your data missing, we were not using this particular station. We then assessed the trends using the man candle test, which is a robust trend detection methods. And from there, we then performed a stationary frequency analysis, which is what is currently prescribed and practiced via SANRAL as well as SENCODE. And then from there, we performed a non-stationary frequency analysis. In this case, we varied our mean as a function of time as well as rainfall. So we only looked at what happens when you vary just the mean in this particular study, but there are several studies that look at what happened when you vary the mean and the standard deviation. And we also looked at, in terms of our non-stationarity, we looked at it singular, so there was no time and rainfall as a combination. We only looked at one, but there are several studies that look at that, which is something that we'll probably be zooming into or looking into as we proceed with the study in terms of the overall PhD. And then from there, we evaluated and compared the stationary versus the non-stationary approach. So the results for the flow data for the east coast of KwaZulu-Natal using the man candle, as you can see there, that predominantly most of the stations are showing a negative trend, but the word that you get to see there is that it is insignificant, and I've said that it is insignificant with the significance test done at 5%. So majority of the stations that we looked at along the east coast of KwaZulu-Natal, we found to have an insignificant negative trend, with only one station, which is W4H012, that showed a positive significant trend. And then from there, we then did the analysis of non-stationarity. And in terms of these two maps which I have here, these maps only focus on when you use time as a covariate. And if you can look at the pointers there, majority of those black dots are the stationary approach, which are more than the non-stationary approach. So in terms of what we then found when we performed a comparison using the AIC and the BIC, we found that when you use time as a covariate, the stationary models actually outperform the non-stationary models. And then we then moved on to the second phase, where we then looked at when we use rainfall as a covariate. But I also need to throw this out there. So in South Africa, when we perform these studies, compared to other countries, we actually don't have much of the privilege of having a weir gauge that also measures other climatic variables like temperature and rainfall. So what happens is you find that the weir gauge is isolated from a rainfall station. So when we wanted to perform a covariate to see how it's performing when you're using rainfall, it posed a challenge. And what we then ultimately did is we decided to look for all rainfall stations and weir stations which are found within the same quinary scale. And the assumption, of course, there is that within the same quinary, the climatic conditions are similar, and so we use that. But when we were doing the screening criteria looking for stations, we could only find 5 stations which we could use. But then we proceeded with the 5 that we used. And when we looked at rainfall as a covariate, we found that when rainfall is used as a covariate, it actually outperforms both the stationary and the non-stationary with time as a covariate using the AIC and BIC. And so, of course, as I highlighted when we were going through the methodology, the first thing that everybody said is it potentially could not be climate change, it just could be abstractions upstream. So then we looked at the rainfall. In a previous study done by Caitlin, which is my supervisor, she looked at what has been happening to the annual maximum series each year. And she also found that majority of her stations were showing a negative trend in the annual maximum series. And so because, of course, with so many results of climatic models saying your results are becoming more intense, more frequent, we saw it fit that we perform a rainfall analysis as well, but using the peak over threshold approach, which will give us more variables within a year than the annual maximum series. And I'm just going to show you just 2 stations. One of the stations is station 11 along the data that we obtained from SASRI. It's open data from the SASRI website, which everyone can have access to. So when we looked at the station, what you can see here that I'm trying to show is when we look at the peak over threshold, we have 2 approaches. We looked at the magnitude of the 95th percentile all the way to the 100th percentile. And as you can see there, that you have varying relationships, with some of them increasing. But the common thing that you get to see that in the past, you've had bigger events than you have seen in recent years. And then even if you look at frequency of how many times these events have been happening within a year, how many times the 95th percentile has been exceeded, you can also see there that in the past you've had bigger events occurring several times. And but the common thing that we can pick up from the data is you can see the peak over the last 5 years, where you can see that in terms of occurrence of events, it has been increasing. And I think this is one of the reasons why people are feeling this impact. But it's not as big as something that we have seen in the past. For instance, in that year, 2000, you had close to 15 events which exceeded the 90th percentile. Compared to more recently in 2022, where you have around 10. But you can see that there has been that spark in recently. And we did the same with all the stations. The graphs were just a summary. If you look at all the stations, you can see that majority of your stations are showing a negative trend. So in conclusion, the rainfall analysis that we have done here indicates a weak evidence that the daily rainfalls have increased in magnitude and frequency over time. The trends that we have detected in the magnitude of the extracted daily rainfall varied across the different sites, but with only 22% of the sites showing a negative trend. And the results of occurrence, only 20%. When you look at, in terms of stream flow, the data indicates that 79% of your stations are showing a negative trend. Whenever you perform a non-stationary approach with time only as a covariate, the stationary models outperform the non-stationary models. But in future, we recommend that other covariates that influence stream flow are looked into. And thank you very much. Thank you.
Thank you very much, David. I think looks like I thought you'd overshot your time, but looks like you just squeaked in. So well done. I'd like to open the floor to questions. So I think this is a very topical study, very necessary, I think, from a design point of view. We're all hearing about climate change. We all have a perception that magnitudes are getting bigger and the events are happening more frequently. But certainly some of the studies we've seen so far is not showing evidence of that. So I think humans have got short memories. We forget about what happened 20 years ago or 30 years ago. But, and I guess the other issues related to that as well. Any questions from this audience or online? Maybe just a quick, Kanesili, please go ahead.
Thank you, Prof. This is Kanyisile Mngun. Damien, I just want to ask from you that you've shown that there hasn't been any major rainfall that has been occurring compared to the past. Maybe then what would you say was the reason behind the floods that are currently occurring right now that you are seeing in South Africa, all over the country?
Okay, I think first of all I must highlight that it's important that we do these studies that we're doing now, so that we can deal with the actual problem. The first thing that I want to say is that when we speak about floods, every time when you talk about floods, the first response you get is it's climate change. And once somebody says it's climate change, that's the end of the topic. But we don't want to find ourselves in a situation where it's not only climate change and we have got other reasons. In Durban, I think if I were to speak about eThekwini municipality, they've been doing a lot of work on clearing their alien invasive plants, because these plants, when there are events, even if it's not large events, they wash off, they block your culverts, and then you have overtopping of your drainage structures. That's the first thing. But I think at another level, if we have issues with potholes which are on the surface, then what more about the drainage which is underneath the ground? And I think these are things that we really need to zoom in, things such as maintenance, where you're not having maintenance of your storm and drainage systems. Of course, it will lead to overtopping and excessive floods. So I think that answers some of the speculations, I guess, if I were to put it like that, that we might have.
Thank you very much. Yeah, I think we need to look at how urban developments are happening. People living in inappropriate areas, in floodplains, and it's no wonder that we're getting more impacts on humans as a consequence of floods. So thank you very much, Damien. I don't see any other questions online, so let's, one last question.
Thanks, Prof. Thank you for your presentation. My question is just around the point that you made about there's a sort of a lack of rain gauging stations near gauging weirs. Would you, in your personal capacity, take this research and use that as a motivation to the relevant authorities or companies or whatever to help set up those networks to further the research?
Yeah, I think that's the nice part sometimes about research, is that when you're doing the research, you tend to answer some of the research, which is not necessarily, close to what you're trying to do. And I think we get opportunities to present our work at places like the ARC and places like the WRC, which we've been raising these things to say it's something that will be relevant, that if you have, because the instruments is already there, just add another sensor that looks at other things, so that when somebody does a study in future, they do a comprehensive study. Yeah.
Thanks very much. Thanks for the question. That I think it certainly opens up a whole new can of worms of access to rainfall data, for example. Very difficult to access up-to-date rainfall data, or very costly. So it depends if you've got big pockets or not, which is a pity when we're working in the research field. But let's not open that debate. So thanks very much, Damien. I'd like to call on our next presenter, is KwaZulu-Natal UMNGENI. She's going to be talking on modeling, assessment, optimization of rules for selected UMNGENI water distribution systems.
Greetings, everyone. As introduced, my name is KwaZulu-Natal UMNGENI, and I'm going to be presenting to you a master's study I'm doing in modeling, assessment, and optimization of UTHUKELA water operating rules using a water net advisor for a selected UTHUKELA water distribution system. My supervisor is Prof. Kumarasamy and co-supervised by Prof. Smithers. Okay. The overview of the presentation is the introduction or the background on the problems and the aims of and the objectives of the study and the methodology and the optimization tool that is going to be used to achieve the result. UMNGENI UTHUKELA Water is one of the largest water utilities in South Africa, supplying water to the most parts of KwaZulu-Natal. Like any other water utility, they are faced with problems such as the increasing water demands that are expected due to the increase in population and the high pumping costs that water utilities use. In UMNGENI Water, they are using 60% of their energy is used to pump in the pump stations. There's also high non-revenue water in KwaZulu-Natal that could amount to 2.1 billion rand per annum. Their system is also simple controlled, meaning that the operation is based on water levels only. Yeah, and then with these increased leakages, increased demands, and the simple controls, they tend to increase the operational cost and the system inefficiency. So water utilities are looking for ways to improve the efficiency of energy use. Energy use can be reduced by modifying pump patterns, pressure management, and modifying pumps. For this study, will be focused on modifying the pumping patterns. So the aim of this study is to develop pumping schedules to reduce operational cost, increase performance and energy efficiency of the selected UTHUKELA water distribution system. The objective is to review the methods that are being used to develop these pumping schedules, develop an optimization problem for the system, model in EPANET and in WaterNet Advisor, identify an optimization technique that can optimize the system and develop the pumping schedule, optimize the pumping pattern, and then evaluate the feasibility of the developed pumping schedule using WaterNet Advisor. This is the general methodology where I did a literature review study and then model in EPANET, and then developed an optimization algorithm that will be used for the Howick West subsystem, and then we evaluate the feasibility of those pumping schedules. So in order to develop a pumping schedule, you need to have access to data that you can get from a SCADA system, and then that data you feed into a hydraulic simulator with the demand forecasting, and then you use the pumping schedule tool to develop the pumping schedule and then send that back to a SCADA system. This is more applicable in those real-time pumping scheduling generation. In the research that I've come across, they now motivating to do multi-objective optimization when it comes to pump scheduling, because the water utilities now are not only looking to reduce the operational cost, but they're also looking to reduce leakages, increase the resilience of the system, and also reduce the number of pump switches, which has a direct impact on the operational cost. An example of a pumping schedule that was developed by Costa and others, that is constrained by the tariff structure. It shows that how the different pump combinations in a pump station that has 3 pumps will normally look like. So some of the findings from the literature that show promise and motivation for this study was that by using the multi-objective optimization, you are able to reduce your water losses, reduce the pressure that you are working, the working pressure, and also you're able to reduce operational costs by 26%. And it also shows just by adding the constraint of energy tariff can further decrease your operational cost by 15%, taking advantage of the night tariff. So, and the best performing optimization algorithms that I found was the non-dominated sorting genetic algorithm, which is a heuristic model that is based on genetic algorithm. It takes in multiple functions, and then we have the branch and bound and the goal programming. The goal programming has been used for real-time optimization, and is based on the linear programming. Yes. And then this is just the overall methodology, the modeling, calibration of the model, problem formulation, optimization. Then we have results. In terms of the case studies, we are going to be doing 2 case studies. The first one being the Richmond Real Water Distribution System in London. This is to validate the optimization tool that we are developing. So once is to validate and also compare the results that we'll get from our model with the one that is already available in literature. In terms of the system that we've chosen at UMNGENI, we've chosen the Howick West subsystem that runs from Howick to Vulindlela. The system has a capacity of 236 megaliters a day with 13 reservoirs and 22 pumps. It is located in the Umsunduzi local municipality. The system is modeled in EPANET and WaterNet Advisor by UMNGENI team. In terms of the optimization problem, I'm going to be, firstly, the first objective function will be to reduce the operational cost, and then increase the reliability of the system, and also reduce the number of pump switches. The constraints will be operational cost and hydraulic constraints. The variables will be the number of pumps. This is the scenarios different scenarios that we'll explore. The base one being the scenario that UTHUKELA is currently using, where they are using simple control, which is water levels, controlling the system based on the 90% and 60% in their reservoirs. The second one will be to introduce the energy tariff structure as a constraint, and then also constraining using both the energy tariff and the water levels. And the last one will be to use fixed time steps, and then we compare. The optimization algorithm that we are using is the non-sorting genetic algorithm. It can take multiple objective functions, and it can be linked directly to EPANET using MATLAB. So there's a MATLAB toolkit that we are using. It runs different scenarios to try and find the most optimum solution for the pumping schedule. This is just a sample of the model or the main function that we are using, where you have your number of variables being the number of pumps for that particular water distribution system. What I've been able to achieve with this is that you can run any other EPANET model, so it's not only going to be limited to the chosen case studies. You can input an EPANET file of a different water distribution system, and also you just have to add the different pump details as to those different models that you are using, and then you are able to use this to develop the pumping schedules. When we are calibrating the EPANET model, we saw there was a need to check because the system that I'm working with has pipes that are as old as 41 years. So the first step was to calibrate that model and look in terms of how much the roughness factor has changed, because that directly affects the operational cost and the energy that you will need. Then we found that the roughness factor was changing by 0.036 millimeters per year, and that has it's for some pipes, especially a steel pipe, it has grown 20 times more than it was initially when the pipes were being installed. So that will be taken into account when you're calibrating the EPANET model. So most of the data that I'm using in my study, I received from the SCADA system at the Howick West, the measured flow rates and the pressure, the reservoir levels and the water quality. The observations that I have is just to show that in the second graph here in the Groenskloof reservoir level, as much as the simple control says that the water level must be between 90 and 60, it shows that some other times they have to operate with water levels very low in their reservoirs because of some constraints and the increase in demand, and hence this study will try and under those conditions still able to develop a pumping schedule to satisfy those needs. In discussion, the modification of the pumping pattern will not require any change in infrastructure for the water utility. And the hydraulic models and optimization problem, they need to reflect the real world conditions as much as possible. And the non-sorting genetic algorithm too has been proven to be able to work for real world water distribution systems and finding the optimum solution. And about 30% of cost can be reduced, and we're hoping to achieve some of those figures. In conclusion, UTHUKELA can benefit from modification of their pumping patterns by introducing the energy tariff constraints, reduction in pressure, and also controlling the number of pump switches, and this will reduce the maintenance cost. Challenges that I'm having in my study is that WaterNet Advisor cannot be run outside of UMNGENI water network, so it needs to be run on site. There's this model, the heuristic model that I'm using, it requires a very high computational power, so the system tends to take more time to run. and also the parameterization of the non-sorting genetic algorithm too. There are no standards, so everything when it comes to the population size, the mutation rates, and all those figures, they have to be used on trial and error. So those have been the challenges, and thank you.
Thank you very much, Kanisile. I think this is a very example, I think, of some of the issues we were talking about, and Dr. Depa highlighted last night and this morning about energy efficiencies and water use efficiency and reducing our greenhouse gas emissions by reducing our energy usage. So that's really, really exciting. Very good to see it. And making a real difference on the ground, a potential 30% saving, I think that is very significant. So that is really wonderful. Opening the floor to questions.
Thank you very much for a presentation. Oh, sorry. My name is Dr. Chokozani Mngube. Your presentation is actually relevant to our operation. And that's the first thing that I liked about your presentation. And secondly, you said it's a master's program, right?
Yes, it's master's.
Okay. I would really like to see the final result of this project, because there are a couple of few things that we still want to consider on the MATLAB and Aspen Plus. But when you already working on the modeling using MATLAB, and I think that will actually add value to us, because we really wanted to do a lot of modeling and the work you are doing. And another thing that I would really appreciate, try to not to be generic with numbers, because there are a couple of numbers you put in. When I then do some calculation, your tariff was way out. So, but I did appreciate with your presentation. I understand it's a master's level, so we don't have to be fussy. But I would really appreciate to see this project going forward. Thank you.
Okay. No, thank you.
Thank you very much for those comments, Doctor. Yeah, I was going to suggest that a tea time discussion needs to happen. We've got the supervisor here, a main supervisor, Prof. Kumasamy.
Thanks, Kanisile. I'm Prof. Kumarasamy. Maybe you didn't highlight one of the things about how do you trigger the EPANET model from MATLAB in terms of switching the pumps. Maybe if you can explain, that will be useful.
Okay. Can you bring my presentation to the slide? Sorry. But if I can explain it without that. So the model that I'm using, the first thing that you do is you initialize it. So let's say you have 3 pumps, and then you're going to have it on, and off. So you first feed that information to say I have this state of my pumps. So here, this whole chain is how you do that. So you run the EPANET using the first configuration. So if you have your pumps on and off, you run that first, and then you run the fitness function. It's gonna say your pump 1 is on, so the cost of running this pump is gonna be this much plus this one, plus the other one, and then it evaluates that total cost, and then it goes further to check the feasibility and the constraints. And then when it has done that, it develops another population or another pump setting. So now maybe pump 1 was on initially, and then now it's gonna say maybe if we open pump 2 instead of pump 1, and then once it has that, it goes back. The code I instructed to say take now that new pump setting and feed it back to EPANET. It runs again, and then it evaluates the cost of running that particular pump scheduling, and then it takes that out, and then it does that iteration up until it finds the best combination of the pumps that reduces the pumping cost, increase the reliability, and also while minimizing the number of pump switches. So it looks in terms of maybe you've been switching on and off pump 1. How about we leave it on for maybe 4 hours instead of opening it every 2 hours, because that kind of damages the pumps. So that's how the model will look and go all the way around to find the best pumping schedule.
Thanks very much. I think if we can have one last question, if it's a short question.
Thank you very much. That was a very interesting presentation. My name is Samuel Getavon from Wash R&D Center. My question on your model is that you mentioned that you validated the model using literature data. How did your model did against that literature, and what was acceptable in terms of prediction? Have you done sensitivity analysis? And last question, how can we use the model for other treatment works? Thanks.
In terms of running simulations and checking, I haven't been able to do that. As I've said, that the model, I'm still figuring out the parameterization of the non-sorting algorithm. So I haven't received any, been able to get any successful runs in my model. But we'll consider that, and then in the sensitivity part. And then I think in terms of the water treatment works, because this is mainly for pump applications, so you will be having pumps in that system, and if you can model that in EPANET, and then you can have an EPANET file that you will just feed it into the model, and then it gives you the best pump combination looking to the scenario that you have there.
Thank you. So still a work in progress. We look forward to seeing your future results. Thanks very much.
Okay, in line with what you had said, and UTK also mentioned, that I'm hoping that as you declaring like 30% of reductions and so forth, have you actually established the baseline now, so that as you finalize the project, you would be in a position to indicate exactly how much savings you would have realized? So to keep that at the back of your mind, this is one of those key initiatives. Obviously, the rest, the three that have been presented thus far, are as crucial. But we need to be showing to the board that, look, we implemented this project, and this is exactly where we started off. And these are the savings that we have actually realized. And it also traverses the energy management efficiency plan, Toby, as well, because it touches on day and night tariff shifts, and it's one of the initiatives that are in our energy management plan, that as we do those shifts, how much energy savings are we actually realizing? So I'm seeing it as very multifaceted, and it definitely needs to ensure that we are encompassing the requirements of the board on the return on investment on the initiatives that we are undertaking. And I think this is going to be one of those typical ones where we can declare those savings and the return on investment. Thank you.
There's the main supervisor. We can please talk to each other over tea. Maybe if I can just clarify. I think the 30% that you were talking about, is somebody has reported that in literature. It's not based on her particular study, her study to date. That's still unknown what your results going to look like. But I think certainly there's a lot of interest here. We need to make sure that we do connect up. Prof. Kumasami, I think you need to start looking for some more students as well. Looks like there's lots of work for optimization, looking for losses, reducing energy costs. There's lots of work to do. So thank you very much, Kanyasile. Let's move on to the next presentation.
Thank you.
All right, we're going to move on to our last presentation before a short tea break. It's going to be given by Mr. Glenn Mkonta. Is going to be talking about the evolution of coupling of hydrologic and hydraulic modeling to enhance the predictive accuracy of flood forecasting in the UMNGENI River, South Africa.
Thank you, Chair. Greetings, ladies and gentlemen. Standing before you is introduced as Glenn Mkonta. I'm here to present on a systematic review of hydrologic hydraulic model integration for enhanced flood forecasting in South Africa. The perks of presenting after a number of presentations within the same category is you get to brush through the introductions. I think they have spoken on how flooding is an issue, but maybe just to touch a bit, flooding is known as the most common catastrophic in natural disasters, particularly in South Africa and globally. It contributes to annual losses in terms of economics, environmental degradation, infrastructure, you name it. And in South Africa, coastal and river flooding are known as the most common, and they are mainly due to anthropogenic influence and climate change. But as Mr. Mokansis alluded earlier on, that anthropogenic influence is proving to be the most contributing factor to the flooding in South Africa. KwaZulu-Natal, the province we're in, is extremely vulnerable to extreme weather events, mainly due to its geographical location between the warm Indian Ocean and the cold Atlantic Ocean. It makes it prone to a lot of cut-off flows, as your climatologists would say. So it is very, very crucial now that we have a precise flood predictions and focus in flood early warning systems so to mitigate the impacts of flooding. And then, so we need to make sure that we are able to choose when modeling a hydrologic or hydraulic or both hydrologic and hydraulic model to sort of give a sense of flood modeling in South Africa. So the choice of either using the hydrologic, hydraulic, or both affects the accuracy of flood prediction of the events. But literature reveals that to maximize the flood accuracy, it is advised that we couple or integrate both hydrologic and hydraulic modeling. So just to give maybe a bit more background to my research, what I'm trying to do, I was privileged, my colleague and I, Nicholas Biarawanga, was doing his PhD under the same project. And the supervisors published a paper on the 4th of June, where we're looking at the evolution of flood prediction and forecasting models for flood early warning systems. So it was looking at all models, deterministic, your data-driven models, your machine learning models that are used in flood forecasting. So we're able to uncover that scientists are gravitating more to data-driven models and machine learning models. But the challenge is they require big data sets, which areas like UMNGENI may not necessarily have. So we have to look for the next best alternative, deterministic model, hence what we're trying to do in this particular study. So we're trying to identify the best models to couple or to pair the hydrologic and hydraulic to model the floods. So with the criteria we're using in this particular contest is the accuracy, the coupling feasibility, and as well as the cost of free availability of the models. And then looking at the aims and objectives, this is part of an overarching project funded by the WRC that seeks to develop a flood early warning system, particularly for eThekwini. So there are existing systems, but what we're trying to do here is we're trying to identify the model pairs in terms of hydrologic and hydraulic model for coupling them and then sort of developing a flood focusing system using those particular models. And then the objectives also include examining the most popular coupled hydrologic models as reported by literature to see what literature reveals in terms of the trends and popularity and sort of to choose identify the pair that we can use. The other objectives also include now providing an overview to scientists and sort of contribute to the pool of knowledge of the chronological evolution of the coupled hydrologic and hydraulic models and the evolution in the context of flood forecasting. And then moving on to the methodology, as I've alluded earlier on, this is a systematic review. So it included 4 basic steps, which include your identification, screening, eligibility, and inclusion. Now, in the identification phase, we used mainly Web of Science and Scopus and not Google Scholar, mainly because these databases are known as the largest, they're known to have the largest data sets. Google Scholar, we found that there's a lot of duplication with the papers that we've already found on the 2 databases, hence the exclusion. So after identifying, we then screened, exported the data from Web of Science and Scopus, and then sort of screened to remove the duplicates using the title. Then we filtered as well using the abstract. And then in a nutshell, we ended up having 52 papers or articles to work with after the whole screening and eligibility and inclusion phase. And then moving on to the results. In terms of the distribution in years, we found that, as shown by the results, you may see here that 2019 has the high, well, the spike in the number of articles is particularly in 2019, but the highest is 2022. So we tried looking at the international disaster database to sort of establish why this could be. We looked at the mortality rate over the period, and we found that there's no direct link between the mortality rate and the frequency of floods to the trends that we see in this particular graph. But then, as you may recall, I think the SDGs were launched in late 2015, and then that means that we had more funding to pursue studies related to flood forecasting, to flood modeling, and sort of alleviate the impacts of flooding. So our projections are that post-2015, more funding was available and more technical support was available in terms of expertise, hence the more studies in flood modeling and flood forecasting. And then when we look at the graph below, the countries that are with the highest number of articles in the study, USA emerged as the highest, particularly because they're known to have the highest number of experts, particularly in flood modeling, and but once you look at the collaboration, you find that USA has been collaborating with other countries like your China and your Vietnam. Then Vietnam here is second because it is known to be the most affected country by floods globally, as reported by literature. And then moving on to the journals, just to brush through, Journal of Hydrology and Water Switzerland through MDPI were the highest journals with the highest reviewed articles. And then coming to the real stuff, the hydrologic models and the hydraulic models that are popular as revealed by literature. We found that HHMS and HECRES are the models that are being used the most in flood modeling in globally. And then also looking at now the pairs, the coupling, hydrologic and hydraulic, we found that both HHMS and HECRES as coupled models are the predominant models within the flood modeling space. And then we also tried then to track the evolution, to put a sense of time frame to it. Pre-2000, how were the trends in terms of the coupling? And we found that it is difficult to sort of establish a trend, particularly pre-2000 and 2000 to 2010, because we have standalone case studies of the different models that are being paired. But then when we jump to post-2010, which is the green circle on the slide, we see a huge spike between HHMS and HECRES, which now shows us that scientists were beginning to use or were using HECRES and HHMS more to actually model floods. Again, we also see HECRES and the weather research and forecasting model, WRF Hydro, also are merging with, I think, 2 studies. Also HECRES and the watershed modeling system combined with HHMS. So in terms of the combinations of the models or the pairs, this is what we found over the different time periods. And then coming to the examples of the most popular models coupled, this is just to give a sense of the example of case studies in which the most popular pairs were used and the accuracies. If you look at HHMS, the 3 different studies that we used in this particular context found that the accuracy is between 84 and 99% in terms of the accuracy. And then when you look at the watershed modeling combined with HHMS and HECRES, we found that the range is between 80 and 84% in terms of the accuracy. And then the weather research and forecasting model hydro combined with HECRES, we found that it ranges between 70 and 84% in terms of accuracy. And then moving to the discussion, I think in the previous slide we have seen that HHMS and HECRES is proving to have actually a high accuracy. So why then HHMS and HECRES? One, because of the easy integration and compatibility. It's very easy to work with these models, and they do not require really an in-depth technical knowledge or know-how of to run them, and the fact that it is very easy to transition seamlessly between hydrologic model and hydraulic model because they are built on relatively the same framework. Point number 2 is that both HMS and HECRES are free availability. They have free availability and are widespread. As Dr. said, we're trying to lower the costs as much as we can. So other models require you to pay license fees and all that. But these models are proven to be accurate and they're free. So cost is on our side and accuracy is on our side. So why not use them? Again, we found that they're user-friendly and they're flexible. So they do not require much of a technical know-how, as I've said earlier on, of how to run and operate these models. They're pretty much basic, allowing, and they are posing as preferred options to professionals to run flood models or to actually model floods. And then last but not least, the models, HMS and HECRES, are continuously updated, and with the updates comes enhanced capabilities. So the Hydrologic Engineering Center, which is responsible for developing these two models, HMS and HECRES, ensures that they constantly update the model and sort of improve. I think a few years ago we were using HECRES 4.2, but now we're sitting at HECRES 6.0. Years ago, we could only model one-dimensional flood inundation, but now we can do 2D models. Now again, and I mean, recently we were able to do 2D modeling. Now we can actually couple 1D and 2D modeling to sort of enhance the representation of our results. And then moving to the conclusion. We've seen in this discussion that the hydraulic modeling coupling is significantly advancing. We're having more accurate models, we're improving in terms of accuracy. Number 2, the coupling on its own enhances system accuracy compared to standalone models. Modeling using hydrologic model or hydraulic model alone yields a less accurate result compared to coupling the two. Again, the main challenge we find though in the coupling is that we have lack or incompleteness of high resolution data. In almost all the conferences I've attended this year that are speaking about modeling, this seems to be the recurring problem. Lack or incompleteness of high resolution data. How do we fix this? We use imagery. We use LiDAR and remote sensing to get a sense of more precise inputs. This does not mean that we're substituting this, but in cases where we do not have the data, these serve as best alternatives. So again, the cost of free availability, the accuracy, and the ease of use of models are proving to be crucial factors when picking models to pay for hydraulic modeling. And then last but not least, HMS and HECRES are proving to be the ideal pair for flood modeling. 1, because they are free. 2, they are accurate. 3, they are very easy to use and to integrate. And last but not least, they're also easy. They have visualization tools. You don't have to import now to GIS software where you have to visualize in GIS software. They actually have built-in GIS software that allows you to visualize everything that you need to see in terms of floodplain dynamics and river characteristics. Ladies and gentlemen, allow me to take this time to appreciate the WRC for the overarching project, UMNGENI UTHUKELA for making it possible for us to have this platform to present and even be able to undertake in research. And then last but not least, the University of KwaZulu-Natal through the CRRR, which actually helps in patiently molding us to be young professionals. Ladies and gentlemen, with that being said, I thank you.
Thank you very much. Thank you very much, Glenn. Again, I think a very relevant topic. I think we're all increasingly aware of floods and what need and the ability to forecast them. And I think particularly as people are living in more and more vulnerable positions, the better forecasting we can do, the more disaster management or preventing disaster management we can be proactive about. Can we open the floor to questions? Any comments or questions, either online or from the audience? Thank you. I've got a question at the back.
Thank you. Good morning, Glenn, and good morning, colleagues. My name is UTHUKELA from UMNGENI Water. I just wanted to find out in terms of your methodology when doing the systematic review. Did you only include open access publications or you included even those that are behind the paywall?
Oh, sorry, my bad. I should have highlighted that. It's only open access because we do not have the means and funds to pay for all the papers. It's open access. Maybe I should just go over the stream. Open access, excluded conference papers and only included peer review articles. What else? Yeah, open access, peer reviewed articles, and only used Web of Science and Scopus.
Okay. So in terms of that, I came across a comment. They said, because most of the systematic reviews used open access publications, you might find that your frequency analysis will say you get more publications in 2022, but that might not be the case. It might be that maybe in 2011 you had more publications, just that most were not in open access. So you need to do a normalization of your review.
I think Mr. Btelezi to just elaborate on that. It's a challenge that we can ideally, if science was what it should, we wouldn't have cases where research is locked in files whatsoever, because we are supposed to build on what someone else has built. So I think it's a limitation in the study, the fact that we're using only open access, but we can't do much really. We have to work with what we have. Yeah, appreciate the comment though.
Thanks very much. I presume the journals that UKZN has access to were included, whether they are free or not. So it's not only free access, it's kind of free access plus the journals that UKZN has subscribes to. Thanks.
Yeah, this is very nice, very important work. My question is, how would you find the model parameters? Some models may use different grid spacing or model setting, or their model equations could be different. In coupling these models, how would you, what would be the difficulties or challenges you would have?
I think one of the criteria I mentioned was the coupling feasibility that we consider when combining these two models. For an example, HEC-HMS and HEC-RES are built on more or less the same framework. So, but you have cases where you can, okay, let me answer like this. To couple these two models, at some point, you must go to the back end of the model and run a script where you're actually combining the two models and automate the process, because we're looking at continuous simulations here. So going through a back end of a model that's running through another script or another coding language versus another is almost impossible. So the coupling feasibility is a very, very important factor, which is why we present such pairs, because they are very compatible and seamless to sort of integrate and navigate through.
I'd like to move on to our next presentation, which is going to be done by Tabani Ngwaze on an assessment of radon level in aquifers along the UMNGENI catchment, health and geohydrological significance. Over to you.
So, greetings, good people. My name is Tabani Ngwaze. I'm an MSc student that is supervised by Prof. Seifu. Today I'll be telling you about my research titled An Assessment of Radon Levels in Aquifers Along the UMNGENI Catchment from Health and Geohydrological Significance. So, back in the years, the main focus have been mainly on surface waters, but in recent years, the focus now is shifting towards the groundwater. And the reason for that is that surface waters are much vulnerable to pollution and human interference. So my research is based on radon. So radon is a radioactive gas that is formed by the decay of uranium and thorium. It has a half-life of about approximately 4 days. So what does that mean? It means that if the concentration of radon in water is about maybe 100 becquerel per cubic meter, or let me just say 100, if after 4 days, half of radon decays. So if the concentration of radon is 100 today, after 4 days, it'll be 50. After 4 days, it'll be 25, and so on and so forth. So it's abundant in groundwater because it's mainly found in rocks that host uranium. And scientists usually use this gas to trace water. They use this to study surface and groundwater interaction, and also a water quality indicator. So, for example, if your water has a high concentration of radon, that means that the water is not safe to drink. So, this was a study that was done by UKZN students, which actually triggered my research. So, this study was done by Tobeka Mpungose in the UMNGENI catchment, and she found the highest radon concentration from where I circled. And then my supervisor saw the need to do the study further because Tobeka's study began in 2022 and it's ended this year. So why does radon in aquifers matter? It matters because it's a fatal gas that kills people. So as you can see there on the yellow bar there, it has caused like deaths of about 1,000 of people. And the challenge that it has is that it is invincible and is easily ignored. And that is because it is colorless, odorless, and it's tasteless. Some people judge water just by looking at it. So the water may be clear, but it may not be safe to drink, even though it may seem to be clear. So the research problem that we have in South Africa is the knowledge issue. Most studies that I've come across only focus on radon in water, not only in air. My study focuses on radon in water and in air. And I've read a few studies, but I haven't come across a study that was done specifically in the UMNGENI catchment that's doing exactly what I'm doing. And there are gaps in the monitoring procedure that do not measure variation of radon in nature and groundwater. So by that, I mean that a measurement of radon that is done once in 10 years may not fully capture the variability of this radon gas. So the literature review put an emphasis on the fact that scientists use this radon gas as a tracer to study surface and groundwaters. And also it has health risk impact. For example, the Environmental Protection Agency in the USA estimates about 21,000 death cases per year. And 2,900 of those death cases occur from people who never smoked. I will repeat that. 21,000 death cases occur in the US. And 2,900 of those occur from people who never smoked. And also, this gas can also be used in mining. So there's a device that miners use to measure radon in air. So when they capture this radon in air, it tells them that there are minerals that are present. So these are there are many studies that are done in South Africa as a whole, but I just chose this one. The first study that was done here in South Africa, it used radon as a tracer, and they were trying to identify the areas that has a high concentration of radon. They found out that radon was more concentrated in shallow waters as compared to groundwater. Well, usually radon is mostly high in groundwaters. So because of this study, they found out that it was present in shallow waters due to the fact that the geology. So they found out that the rocks that were in shallow waters had a high concentration of radon as compared to the groundwater. And the second study that was done in 2017, it was done in Gauteng, which did something similar to what I'm doing, but they didn't find highest concentration of radon in water. So the relationship between radon levels, geological formations, and water quality is that, as I'm putting emphasis on the fact that radon is found on uranium-rich rocks. So highest concentration are usually found on rocks that contain uranium. And the other thing that enhances the radon in water are the fault lines that are in deep underground, which allow radon to escape from the soil and underlying rocks, leading to high levels in water and in air. Another relationship between radon levels and water quality is the groundwater contamination. So as I stated earlier, that this is a water quality indicator. So if I measure the water and I find a highest concentration of radon, maybe for like is like 1,000 becquerel per cubic meters. It means that the water is not safe to drink. But the challenge that the radon has is that it cannot be easily seen with the naked eye. But the treatment that I know of is an aeration system. Since this is a gas, if, for example, your water has a high concentration of radon, you can just expose the water to the air, and the gas will escape. So these are my aims and objectives, which are to evaluate the radiological water quality status of borehole waters along the UMNGENI catchment with a focus on hotspot areas such as aquifers and rocks, and also investigate the drivers of seasonal variation. My aim is to create a surveillance protocol that measures radon seasonally, because radon varies seasonally, and also examine indoor levels among households directly from people that use borehole waters as their main source of water. This is my study catchment, which is the famous UMNGENI catchment. I know a lot of students have done their research on this catchment. It is characterized by a diverse geological setting, and this is a geology of my catchment. So from these, it's not clear, sorry for that. With this alone, this highlights that there are different rocks within the UMNGENI catchment. Since my study is driven by rocks, this alone tells me that my results will be different from different areas, because there are certain type of rocks that has a highest concentration of radon. So the method that I'm using, basically what you see there above is everything that I'm using in the lab at school. So that big brown bottle is where I put my water, and then it sucks in the air of water, it gets trapped there on the dry rights, and then the red 7 detector meter measures radon in air. But then I use this capture model to convert it from radon in air to radon in water. So I go around looking for boreholes and households that use boreholes as their main source, and collect the samples and measure them on site. And then I use this software to analyze my data. So these are my sampling points. Actually, those black dots, these are the boreholes that are in South Africa. But the challenge that I had is that not all of them are active. Sometimes I will drive to a place using the coordinates, because I have a spreadsheet that says the coordinates. So when I drive to a place and then I get there, I may find the challenge that the electricity is not there, or the pump is not working, or people are not even monitoring the boreholes. So I wasn't able to measure samples from all of these boreholes because of that. So far, these are my results from my dry season. As you can see from the previous slide, from out of these boreholes, I managed to find 13 or 14 so far. And the one that I highlighted is the one that has the highest radon concentration. Now, as you can see, there are dikes. So dikes are faults that are underground. So these dikes create a space for radon to escape. So when radon escape, it increases in concentration in water. So my current progress is that I measure rainfall monthly, as my prof said, and then I measure borehole waters seasonally. And then when I go on site to measure the radon, I measure it on site. The reason is that I'm trying to minimize the temperature interference, because temperature can affect my results. The reason is that when radon has the highest temperature, it can increase. So how is the study relevant to geohydrology? So the thing is that it sheds the light on how geology influences radon distribution, since it's a study that focuses on aquifers. So some aquifers have a highest porosity, and they are more permeable. So the more permeable the aquifer is, the more easily it is for the radon to escape. So these are my projected outcomes, which is to determine the existing groundwater levels in the UMNGENI catchment, outline the associated health risk implications. Now, when it comes to health risk, I think I forgot to mention something. So if a person drinks the water that has a highest concentration of radon, it can cause stomach cancer. And through inhalation, when people inhale air that has radon, it can cause lung cancer. As I have stated before, that in the US, they record about 21,000 dead cases per year. So I also aim to understand the groundwater movement within the UMNGENI Basin, as well as the progress in the regions of the hydrological processes, because my aim is to give a person of exposure. I'm trying to understand what drives this radon. Is it the recharge rate, or chemistry, or the geology? So my goal is to develop a surveillance protocol for radon measurement. And in conclusion, my study is still ongoing, and I was able to successfully implement my sampling plan for the dry season. Now I need to develop another one for the wet season, which will commence in February next year for the summer. And the most important points that I picked up from the literature that I read is that this radon is fatal, it's deadly, and it causes cancer. And it's also a water quality indicator. And on top of that, scientists can use this to trace water movement. Ladies and gentlemen, thank you for listening.
Thank you very much, Tabani. Interesting topic. I guess we're all worried about our health and what the implications are. I'd like to open the topic to any floor to any questions.
Have you tested the drink? I'm Megan Skalkwyk from UMNGENI UTHUKELA water. So have you tested the drinking water for any radon? I understand that you're motivating for your project, but we also have to control how the public views these contaminants, and when we say it causes cancer, people automatically get extremely scared. So, I think just to caution on saying that everyone's gonna die. But also, I think it's a good idea also to test the water to say, okay, in our current, what's there now as a baseline, and how do we prevent it from being there if it's released? Thanks.
Okay, my study is focused on groundwater, and the reason is that radon is found in groundwater. So I can measure radon right now, maybe on the tap, it will be 0, because it is a gas that can easily escape in an open water source.
There's borehole, people are drinking borehole water in Ilembe as a bulk supply. So, I mean in that.
Yeah. In a borehole, I might find something.
Thank you. Yeah, so I think a word of caution. So maybe we just need to put into context what you're doing. Yeah, I think that's what you're saying, Megan. Yeah, thanks.
Okay. Thank you very much for your interesting presentation. My name is Usiphumelele Wagwamwandla from UMNGENI Water. Okay, in your presentation, you indicated that this radon varies seasonally. What causes that? If you can explain. And secondly, as well, you are indicating, you put a catchment map there, and then you indicated one spot where you indicated that you find high concentrations of radon there. Maybe if you can, maybe for our understanding, because we work on UMNGENI catchment, if you can maybe indicate where is that, the location of that spot, and also if you can tell us the why you consider is this high. Maybe just give us maybe a variation or just a limit, which I consider high as this number and it causes that. And thank you very much, Megan, for indicating that whenever you indicate that people will die, just put it into context. If you maybe say people, they take that groundwater directly, they might die, because people, we also supply potable water, so people might be confused in terms of that. Thank you very much.
Okay, thank you for your question. I'm not sure if I remember all the questions. Two. Okay, maybe the first one. What was the first one? Okay, in seasonal variation, what's caused the variation is that the richest rates of rainfall. So in winter, we do not get high amounts of rainfall as compared to summer. So when it rains, the water level might rise. So when the water level rises, it comes with this gas. So yes, exactly. So that is why I'm trying to detect. And also the temperature has an effect on radon. So when the water is has a high much temperature, so radon is easily soluble in the water that has a high temperature. So it might increase there. Sorry, what was your second question?
I think the second question was related to what.
Oh, the location is in Dagley. I'm not sure, but it's in Dagley. Yeah, in Dagley.
And I think the third question was, how worried should we be?
Oh,
given
okay.
given at what level do we need to be concerned?
Thank you for mentioning that. So different organizations and companies have different water quality guidelines. For example, the World Health Organization has a guideline of about 100 becquerel per cubic meter. So if they detect radon that is 100 or above, they need to investigate that water because it might be contaminated. So yeah, different countries have different guidelines.
Thank you very much. I don't see any other questions online. We look forward to seeing your completed study and to see the extent of this. It might make us sleep a bit easier. Thanks. Thank you. I think if we're going to be changing tune now, so we're putting together a couple of presentations that are focused on water governance and citizen science. And the first presentation was on work that has been done by Carla Higgs. Unfortunately, she's not here, so it's going to be presented by Professor Trevor Hill, her supervisor. And it's on developing an indicator system to assess water equity in South Africa. Trevor, over to you.
Thank you very much. Right, good morning to everybody. Good morning. My apologies for jumping in and out, but I'm chairing a session upstairs. So I've come from listening to my own students to now being the one doing the presenting. And I think Carla did this to me on purpose. I've been her supervisor. My name is Trevor Hill. I'm supervising this with Richard Meze. And I think she's made me present this morning to make sure I know what she's been talking about. You know, you never trust your supervisors at the end of the day. You know, you give students a topic and it goes in a direction and you just keep nodding. Yeah, I know what you're talking about. Good data analysis, you know, I'll choose the examiners. So the topic, and please excuse me, I'm going to use Carla's notes. So it's more her voice than mine, I hope. So I'm trying not to interpret what she says too much, including the title, which I can see an error already. What Carla was interested in looking at was the idea of water equity and equality. And these are two terms that are bandied around regularly in water policy, both globally and in the South African context. In policies, in legislations, in conventions, we talk about water equity and we talk about water equality. But it's very difficult to monitor, to implement, or manage with these laudable ideas in place unless we actually know what we're talking about, how we define them, and actually trying to set up measurable indicators of what is water, particularly water equity. And so this is what Carla has been grappling with over the last few years. And we started at a global scale, and then we've moved to a more South African scale, with the idea of trying to come up with water equity indicators that we can actually take to stakeholders, municipalities, and run with it. And actually try and put some monetary or measurable values indicators to understand what water equity is all about. So hence the title, Developing Indicators to Assess Water Equity in South Africa. And the approach we adopted was a Delphi technique, something that was slightly different and it's been done before, but we just went with this type of process. Delphi is always quite fun to try and do when nobody agrees with each other. Help me out. Yes, sir. There we go, because I'm now realizing it's coming from there. Okay, so equality and equity, cornerstones of principles of water policy. The concept of equity, we did, the usual reference searches, we did the definitions, we tried to see what was used before. And of course, we came badly unstuck because nobody agrees on what water equity is all about, and it's banded in our constitution and in our water policies. And so we started off by just doing a global search and putting some ideas together, and we were very fortunate we were able to get that published in a Natural Resource Forum, just really dealing with the concept of water equity. And then we brought it a little bit closer to home, and we tried to look at water equity in South Africa, and that is the second paper, and that has already been reviewed, and it's come back with minor corrections, and hopefully it'll be out in the next couple of weeks. So that's quite nice that we've actually now we've got it in our head, we kind of know where we're going with it, and we've defined it, or we've seen what globally it's defined as, or how it's defined in South Africa. And the one thing that is really missing is understanding how to practically monitor for the idea of water equity. I just want to mention there on the second paper at the bottom, you know, I wish the peer review process and the journals would realize I had to stand here and present today and just publish the damn thing. You know, because it would have been nice to say we have 2 papers out rather than 1 paper, you know, saying the other one's almost done, but not quite there yet. Sorry, excuse me. So the research method that we have followed, and I have to admit up front, it's taken a long time. Carla is a mature student. She already works for a living. And so it's been part-time. So it takes a long time to do this. She hasn't had the opportunity of being a full-time student. We started with an extensive literature review, as everybody does. And then we decided through this process that we would go with a Delphi method, a Delphi approach to understanding water equity and to come up with indicators. And that is where we're at the moment. And that's what we just like to talk about this morning, is to let you know as a progress report, this is where we are at the moment. Once we've set up our water equity indicators, which we have now done, we will then do a case studies, which will be early next year, and then that will be just testing and refining to make sure our indicators are in the right area, and then the thesis will be complete. As a supervisor, I'm trying to push her for at least another 2 or 3 years, and she's saying, I want to get rid of this thesis. So the Delphi technique that we've been through, we first of all, set up, after doing a literature review, we set up what we thought would be the relevant questions to find out what indicators we wanted. We then ran through a pilot study, and then we actually decided, right, who do we want to send this to? So the Delphi technique, the idea is that we engage with different stakeholders, different municipalities, different managers, policy decision makers, as many different groups as we possibly can, and get input from them. We then put that all together. We then look at what the different rankings are, and then we give it back to the same people again and ask them, are you happy with this? Does this make sense? And then we take that back in again. So it's very different to your kind of usual focus groups and interview type process. And we were able to get through this by hook or by crook and by bribery at times. We had 128 people around the world that were dealing with South African water policy and water management. And of those 128, the return on the first round of the Delphi was over 70%. So we had over 70% people that engaged with us and responded to us. We used our literature to find out who was working in water. So we got people that were writing about literature. We then went and got people that were doing this on the ground in terms of environmental consultants. We then went to the different municipalities. We went to the different water boards. And then we even threw in a God sprinkling of academics now and again as well, you know, because you've got to keep them happy. But as I said, we got a very good return, and we put together their responses and what they thought would be the best indicators for water equity. We then took it back to them again, and we said, do you agree? Because there was a lot of conflict and people don't agree on this. Of course they don't. And our return on that was over 90%. So over 90% of the people that we went back to and say, please help us out here. So we've had, I think, a very rich picture of water management in South Africa around the water equity issues. And these are the data that came out from it. This is the interest, and we've put them into pillars. The first is around context, the historical, social, cultural, and political situation which communities, municipalities, businesses, individuals see. So there was definitely a pillar around what we've described as contextualization. The second pillar is around human rights. human rights is obviously going to be critical. So this is about looking at your constitution and just the basic water and sanitation surfaces. And the one that we really struggled with where do you put ecological integrity? Where do you put that ecological reserve? Which one of these would it fit under? And for now, we've put it with the human rights kind of idea, if you like. Then under social justice, we divided that up into procedural equity, which is around being involved in catchment management forums, being involved in decision making about water allocation, water licensing, and then distributive equity, which is just your access to your water, your benefits, and burden sharing. So there were 3 pillars, if you like, and under social justice, we had the procedure and we had distributive equity. And this is what, as I said, comes out of the Delphi process. Also, we asked the participants, how many indicators can we have? How deep can we go? Because every issue is so laden on top and so complex, it really is crazy. And they said, we'll give you 10. We took 11. Okay, at the end of the day. And so we came up with these 11 indicators using those pillars of human rights, procedural equity, distributive equity, and kind of cross-cutting themes. Whether it be water quality, availability, accessibility, the ecological integrity, protection of the ecological integrity, we split that into 2, and that's probably our little own bias there. The participation in the process, the representation in the process, and ethicality, just the ethics behind this. We had so many examples in Southern Africa where there were water boards that were driven by governance issues, or they were driven by particular overseas companies, or there was, the ethics behind a lot of this, the hidden meanings that was going on. And then for distributive, we looked at water for spiritual and customary purposes, availability, and then physical accessibility. And then cross-cutting themes is discrimination, and future use of water. That horrible word, sustainability. You notice we left it out as best we could. So these are the indicators that, as a consequence of the Delphi process, that we believe will give us a measure of what water equity is. This just shows one in a little bit more detail, which I'm not going to go into a lot of detail about, but this was taking one of the indicators, which is around water for food. And for each of the equities, they divided up into the impact. Is it negative? Is there no impact? Or is it positive? So the idea is when we take this to case studies, what municipalities or the water manager will do, or the water board, will look at it in terms of, does it have an impact which is positive or negative, or there's no impact at all? So just some final points. And I'm going to read through these because these are Carla's thoughts. So to date, we have 11 context-specific indicators that have been developed to assess water equity in South Africa, a starting point for monitoring equity nationally and at local levels, comparing disparities across the regions. These indicators aim to help the South African government in identifying and addressing disparities in water management and allocation, guiding more equitable decisions. And then finally, the methodology can be replicated by other countries to develop water equity indicators. And as a final point from the supervisor's side, for me, it is actually more about the process that has been gone through. It is about the Delphi approach that has been used, and to make different stakeholders in the water industry think about how can we measure this. We keep banding around this water equity word, but how do we actually measure? How do we make it possible that municipalities can actually question and identify ways of measuring what water equity is? Thank you.
Thank you very much, Trevor. I'd like to open the floor to questions. Megan?
Megan Skalkwyk, UMNGENI Water. I just, will our final output be a tool like a spreadsheet, and it'll just be a tick box, and then they say
It'll be like a wet health. You know the wet health one? That's kind of what we're aiming towards. So it's like any tool, it's going to open up discussions which is going to go further, and we're never going to get a blueprint. But the idea is to help people on the ground be able to have some tangible measurement. Are we meeting this water equity, and what does it really mean to meet water equity? Because that word is not defined in the policies. It's spread all over the place. It's a banded word like sustainable development. Thank you.
Thanks, Trevor. I think it'll certainly be interesting to see the case studies. I think it might get my mind around it anyway, how this is going to work.
Yeah, I think we're all in the same boat. We use the word, but we don't really, we kind of let it go. And the case studies will be done next year. We won't get to the case studies this year. Okay, thank you.
Thank you very much. Any other questions?
Oh, sorry.
Sorry, there's one at the back. Let's make this the last question.
Good day again, colleagues. Thokozisi Buthelezi from UMNGENI UTHUKELA Water. I just wanted to find out if, Prof, you've managed to get any information from the catchment management forums.
The ones that exist, yes. But, it's interesting because we ended up getting too involved in the politics around the CMAs at times, which wasn't good. And you talk to a person that you think is going to help you. And so we're being polite and calling it snowballing, where you ask one and they put you on to the next one and the next one. But often they were more pointing fingers than anything else. I'm going to be honest here, the infighting among some of those catchment associations, and who gets invited to those meetings and who doesn't get invited to those meetings. And I'm not going to name CMAs, but wow, that was quite interesting. Yeah, but yes, thank you. We did talk to the catchment management forums as well. Yes.
Thank you very much, Trevor. We'll let you go on that, and I'm sure Carla also extends her thanks. Our next speaker is going to be Tanisha Curtis. She's going to be talking on an evaluation of the state of citizen science for water quality monitoring.
Good day, everyone. My name is Tanisha Curtis, and I'm from the hydrology discipline at UKZN. And today I'll be presenting on citizen science for water quality monitoring, and specifically looking at river systems. So South African water resources faced a host of challenges, and looking specifically at where we are in KZN, we have pollution challenges associated with agricultural runoff, urban and industrial runoff, as well as metals from mining and waste disposal. Thus, we need to monitor our water resources to know how to better manage them. If we look at this map of South Africa, these are the monitoring locations that the River Ecostatus Monitoring Program covers. Now, this is from the Department of Water and Sanitation's program, which informs the State of Rivers report. So this is the most recent State of Rivers report monitoring locations, and with considering that on the western portion of the country, there's drier regions and non-perennial rivers, we can see that there are still gaps which exist, such as in Mpumalanga, the part of the Free State, and the eastern portion of the Western Cape. At a global scale, if we look at the Sustainable Development Goals, if we look at Sustainable Development Goal 6.3.2, which focuses on the proportion of bodies of water with good ambient or environmental water quality, South Africa has committed to reporting on our progress on these SDGs. And in 2019, the Department of Statistics reported that they had no data to report back on this indicator. And this was accredited due to limited monitoring and lack of funding and resource mobilization. Also, the inability to coordinate monitoring efforts. And the latest country report was from 2023, and the most available data used to report back was from 2020. So again, we can see a gap. So how can we change this narrative of what is going on with our water resources and the story of our water resources? So this is where citizen science for water quality monitoring comes in. So the main overarching aim of my research is to evaluate the potential for citizen science to aid water resources monitoring and management. And looking at more specific objectives, this is also to provide a comprehensive overview of the current state of citizen science for water quality monitoring. And the second objective, which I will keep referring to, is to produce a State of Rivers report from a citizen science perspective. And the third is to evaluate the applicability of citizen science in the broader context of water resources management and how it can aid water resources management. Now, in the literature, there are varying definitions of citizen science, but this definition by UNESCO sums it up quite nicely. So it is a process where concerned citizens, government agencies, industry, academia, community groups, and local institutions collaborate to monitor, track, and respond to issues of common concern, in this case, environmental concern. Now, it's important to note that citizen science can also aid in contributing to research and better understanding of public knowledge of water resources challenges. The point I'm really trying to drive here is that citizen science is not limited to one demographic or one group based on your levels of education or experience in the field. It is very much an inclusive technique. Now, literature has shown that there has been a notable growth in citizen science practices, and some of you may reflect on that as well. And this can be accredited to the affordability of scientifically sound techniques to monitor river health and water quality. There's also growing interest by the public in water resources management, as people can see their impacts on the environment and want to do something about it. And then, of course, there's the potential to overcome the monitoring limitations, as mentioned, due to financial and human capacity. So citizen science is also aligns with our South African legislation, and looking specifically at the National Development Plan, I'll read a short extract from there. It says that the state must actively support and incentivize citizen engagement. If we look at the National Water Resources Strategies, if we look at the Integrated Water Quality Monitoring Policy and Strategy, there's reference that the, what is this thing doing? Oh, sorry. So looking at the National Water Resources Strategy, it mentions that that we should strengthen the partnership with local authorities to be able to meet the needs of our different communities of people across the country. Okay, also going back to the Sustainable Development Goals, Target 6B focuses on community and participation of local communities in water and sanitation planning and management, very much aligning with citizen science in that they are wanting to meet the needs of people, but also encourage local ownership of sustainable solutions and having meaningful involvement of local communities. Again, very much aligned with the notions of citizen science. There are also a number of motivations for the citizen science practices, as it is a non-traditional way of gathering data to inform SDGs and providing a full review of river monitoring systems across catchments, and its method of data collection, which contributes to broader catchment management and can be reliably and soundly used for SDG reporting. And in some instances, such as the study by Bishop et al., shows that the citizen science data can actually better represent what is happening at a local scale than the conventional data. Of course, there's the societal aspect as well, as it helps in promoting environmental education, awareness, and community empowerment, as well as mobilizing and collaborating together towards sustainability. So through this project, I have taken two types of methodologies, so a qualitative as well as quantitative. The quantitative methodologies I'll go through in detail in a moment, but the qualitative methodologies have very much been focused on stakeholder engagement, and this includes going to various conferences and workshops, fortunately, throughout this process, and presenting and promoting this project also through social media and conducting interviews with key citizen science practitioners, and hosting collaborators forums for the broader stakeholder database who is involved in this process. So one of the techniques is called Mini-SAS, which stands for Mini Stream Assessment Scoring System. And this system is actually very useful in that the presence of certain macroinvertebrates, or as we affectionately call them, our hohos, indicates the ecological condition of a river system at that point. So skip the next slide. So you can see, so the green box correlates to a good ecological condition, the orange box correlates to a fair condition, and the red box correlates to a very poor condition. So it's the presence of these macroinvertebrates that informs us, due to their sensitivities in different types of environments, it informs us of the ecological condition of the river systems. So it provides in situ, real-time results. And this technique has been widely applied. It's been applied globally. But just zooming into the Greater Pietermaritzburg area, all those crabs correspond to the different colors correspond to the conditions, and those are all the locations where mini-SAS has been applied just in the Greater Pietermaritzburg area. But a mini-SAS has been done on every continent. The graph also shows an application of mini-SAS, and this was from a river walk where a group of volunteers walked from the source to the sea of UMNGENI along the entire stretch, and at different points they stopped and did a mini-SAS along the stream. So what they found is that how they decided to correlate the different points and the different land uses with the mini-SAS score that is found in that location. And this shows an application of mini-SAS or of citizen science in how the river is able to replenish itself under certain land use conditions. Next is the Clarity tube, which is a meter-long perspex tube, which is used for to indicate the clarity or turbidity of water. There's markings along the tube, and this can track changes before and after events or over time. So if we take a quick diversion to the state of our wastewater treatment works, I'm sure we're all familiar with this, so I won't spend too long here. But there has been an overall decline in our wastewater treatment works according to our latest Green Drop report compared to our previous Green Drop report, where 66% of all our wastewater treatment works fall in critical and high risk categories. And if we look at the spread of wastewater treatment works, we can see between where our wastewater treatment works are laying and where we have state of rivers monitoring locations, that there is a gap. So this is where citizen science can aid in that. So by applications of the Clarity tube, clarity values can be used as a proxy for estimates of total suspended solids. And a lot of research has been done around that. And that graph is an extract from research. And so this can be used to inform ourselves or communities to inform themselves and take this scientific data back to the authorities in order to address what is going on. There are also physicochemical tests that can be used to look at parameters such as nitrates, phosphates, etc. These are freshwater watch kits and water can kits, which I've also applied in this study. And then there's the riparian health audit, which is a way to take qualitative data and make it quantitative to get an ecological condition, which gives an indication of the of the intensity and extensiveness of challenges in the riparian zones, and those are listed there. In the implementation of this whole process, it's been very much stakeholder engagement focused. So we have hosted workshops and promoted this project through these workshops. I've conducted a literature review of the current use and applications of citizen science. And now we're at the phase where this stakeholder engagement has continued throughout, and now we are at phase 6, where we are compiling the final citizen science state of rivers report. So my outcomes are still a work in progress. So these are my expected outcomes, where I have conducted interviews, I have produced the report. We will be doing evaluations of lab data against citizen science data, and also focusing on some case studies across different catchments in South Africa. And I will also be analyzing the capacity of citizen science for water quality management, and of course providing recommendations for future research. Preliminary results show that these are our monitoring locations for citizen science so far. Considering that all this monitoring was voluntary or something that fits in as part of routine monitoring that some organizations already form part of, I think this really shows the value and the uptake of citizen science across the country. this has been a focused effort for the past 7 months, but if people had data from about a year, then we've also included that here. And zooming into KZN, you can really see where these hubs of conservation efforts, where people are residing, working, and conserving, where they are using citizen science. So in concluding, citizen science practices are growing. Not only can they be used for monitoring, but also in terms of environmental awareness, education, and conservation efforts, as well as tools for advocacy. There is growing recognition of the value of citizen science, and it's been sponsored by organizations. This work has been sponsored by organizations such as UNICEF and UNESCO. So the support is growing. So citizen science allows people to have access to information, which knowledge is power. So this has helped bring people into the efforts to protect our water resources. And then, of course, there is alignment with our national legislation as well. So at its core, citizen science is very much required. Thank you very much. These are some of my references.
Thank you very much, Tanisha, for an interesting presentation. I think certainly highlighting the role of citizen science and what we can use it for, and as in this case, as a water quality monitoring tool. So really interesting. Thank you for that. Any questions from the floor or any questions from online? Right. Got a couple of questions at the back, and I'll come back to the front.
Thank you. My name is Ismail Banu. Tanisha, thank you for a very interesting presentation. And I certainly agree, there's a huge role for citizen science in water specifically. So thank you for doing this research. I just wanted to find out, are you guys considering the DWS has already put in place resource quality objectives for most of the systems within KZN? And I can speak specifically about the CMA. At the CMA level, the UTHUKELA, and I'm forgetting the other tributary right now that links into it, but there's resource quality objectives already set by provincial government. And I think it would be nice if your study could show that there's some collaboration between the data you're finding, which is very citizen driven, versus what they're actually mandated to do as a government department. And I think it would be really nice to see if that data actually correlates in some way or form, or augments what they're doing in terms of their reporting in terms of state of rivers and wetland systems. So just to alert you to that, and it would be nice if you can bring that into your study in some way or form. Thank you.
Thank you. Thank you for that comment. Yeah, well, our main DWS resource that we've been sort of aligning this with is the State of Rivers report, but RQOs is definitely something we will consider.
Okay, hi Tanisha. I just wanted to find out about the uptake by the farming community, if you've been able to get any interest from them, because I think most of the diffuse pollution you get from the agricultural land, so we need to know what's the state of their rivers, because getting access there is also quite impossible.
Thank you for that question. I can definitely speak in the UMNGENI catchment. We have had interest, and we do have stakeholders who are from more so smaller scale farming and subsistence farming, who are interested in, for example, using the chemical kits to look at levels of nitrates and phosphates in their streams, especially not only for example, their fertilizer applications, but also for the water that they are abstracting.
Just in terms of the clarity tube, how does the suspended solids indicate that it's wastewater treatment works pollution? Because you can have it from any source.
Yeah. So we are actually looking at this with UMNGENI Water's support as well. So we have sites upstream of wastewater treatment works at the discharge points and downstream. So we will look at the general and special value limits depending on where the wastewater treatment works is located, and do those comparisons and just see what is that change, and then look at the potential sources.
Thank you very much. I just wanted to check, have you done any correlation exercises for the data that you are acquiring from citizen science analysis with that from the lab? That's number one. And also in terms of stakeholder engagement, how can you then influence legislation in terms of this being incorporated into the license requirements? Like you indicating physical chemical parameters that are being done. How can we utilize citizen science data instead of the accredited lab data? And that also goes into the accreditation of the citizen science data, which revolves around the normal or conventional lab data correlations. Thank you.
Okay, I'll respond to your second question first. So I think it's worth mentioning that when people would like to start using citizen science tools, often with the different organizations that actually manufacture these tools, there's training materials available and instruction manuals available to ensure that people are using the tools correctly, because that is the first step before they go out and collect data, because that's a step to make sure that the data that's coming in is actually, there's credibility to it. Does that answer your second question?
I wish we can get to that level where we fully utilize citizen science data instead of the conventional lab one.
Yes. So I think that this research will help us to get to that point by evaluating now how the data is looking compared to lab data. And then, please can you repeat your first question?
I think around the issue of legislation influence.
Yes.
Yeah, how do we, well, it's pretty much the same question that, how do we utilize this citizen science data to be incorporated into license regulation requirements and deem it as credible as the conventional lab data?
Okay. I can see one of my co-supervisors is bursting to answer that question for you. Jim.
Yeah, I think it's such a good point. How can we be sure of the rigor of citizen science? And now there's some incredible statistical techniques you can use, which are called cleaning data techniques, such as normative curve excluders and so on. And there's a famous paper published in Denmark, which suggests that citizen science data is, depending on how the data is cleaned, is more rigorous than conventional science. And so that's significant. The gentleman, your question at the beginning was also very relevant. And there's a lovely paper, 2022 paper, comparing DRAS data with citizen science data. Really worth a read. It was written by the United Nations to see if this citizen science data could work in all countries of the world. So that's a good reference. But just to thank you for that presentation, and maybe to mention that the wastewater treatment works at Howick was always substandard. For 20 years, it produced terrible sewage that went into Albert Falls Dam, which supplies all of Durban's water. For 20 years, nothing could turn it around. The people who live in Shiabazali, which is a township outside the wastewater treatment works, started measuring the outflow with a clarity tube. You saw one of the pictures that Tanisha showed us. Within 1 year of the community starting to measure that, the compliance of the wastewater treatment work started to go up. It was absolutely incredible. The biggest turnaround in water management I've ever seen in my life. That's now been published in a paper in the International Journal of Monitoring. So you can also pick up on that story. So it's showing how citizen science can turn around situations that have seemingly been wicked problems that we're unable to do much about. Thank you.
Thank you, Jim, for that lovely example. I think let's close the questions. Thanks very much, Tanisha.
Thank you.
Let's move on to our last presentation before we... Thanks, Jim. Our last presentation is going to be done by Susan Risco. It's on water governance in the UMNGENI catchment, politics and construction of socioeconomic and environmental values. So Susan has prepared a recorded presentation, and I see she is online to answer any questions.
Good morning, everyone. My name is Susan Risco, and I'm a doctoral student within Development Studies in the College of Humanities. My research is on the water governance of UMNGENI catchment, focusing on politics and construction of socioeconomic and environmental value of the UMNGENI River. To situate you within the location of the study, most of you are probably familiar with this, but the UMNGENI catchment is within the UMNGENI catchment. On the right-hand side, we have the figure of the hydrologic boundaries. The bigger picture is the UMNGENI, and circled in red is the UMNGENI catchment. Now, on the left side of the screen, you'll see the political boundaries. The UMNGENI municipality is the local municipality that fills the catchment. And if you zoom in to the UMNGENI municipality, on the bottom left-hand side, you'll see a figure showing some bright green areas, and this is the traditional authority land. So as you can see, there's, as far as dual governance goes within South Africa, UMNGENI catchment has a mixture of both political systems. The motivation for this research is that the UMNGENI River falls victim to high levels of pollution, including both industrial waste and evidence of sewage waste within the river. For example, the UMNGENI's E. coli counts reach levels greater than 10,000 within a sample size of 100 mils of water. And at times, this value can even be up to 90,000 parts of E. coli within 100 mils of water. Compare this to the World Health Organization's recommended standards, which are for irrigation water, less than 1,000 picocoliforms. And for recreational water, you would only allow up to 10 fecal coliforms per 100 mils of water. In drinking water, you don't want any fecal coliforms. So as you can see, the level of sewage pollution within UMNGENI is not good for anyone's well-being. The pollution within the UMNGENI River places limits on well-being, and this can be in the form of just pure exposure to pollution. It also limits water use options, therefore rendering the river water undrinkable, and it reduces recreational activities. Pietermaritzburg, the industrial city within UMNGENI catchment, holds political and economic significance. It is the capital city of KwaZulu-Natal and the second largest city in the province. From Pietermaritzburg, the UMNGENI River flows to Durban, which is the third largest economic hub within South Africa. This research study aims to answer the question, who are the main actors involved in water governance in UMNGENI catchment? These actors take the form of institutions, rules, laws, and organizations. And what are the dominant discourses of these actors? And how do these actors relate to one another? And where do they draw their power from? Is it, for example, national legislation or participatory governance arenas? The overall aim for this research was to explore the governance landscape, both in terms of politics and power relations of dominant stakeholders within the UMNGENI River catchment, to determine viable governance and management arrangements that contribute toward greater sustainability of the river system, leading to improved water quality and increased well-being of catchment residents and water security for users within the catchment and downstream. There are 5 objectives for this research study. Objective 1 is to identify the stakeholders within the Msunduzi catchment. Objective 2 is to determine and categorize the legal and institutional relations, formal and informal, that define the relations between actors. Objective 3 is to create stakeholder maps that portray socially constructed power relations. And Objective 4 is to determine the dominant discourses, the social constructions, perspectives, political agendas, or strategies by stakeholders. And lastly, Objective 5, to reflect on how politics and the hydrosocial cycle contribute to an understanding of water governance in the Msunduzi catchment with consideration to Southern theory and the geopolitics of knowledge in relation to urban political ecologies, African urbanism. And essentially what this objective means is that it places the study location within the context of the global South and the African continent, which has experienced colonial oppression, and through this oppressed local indigenous knowledge and indigenous ways of understanding or relating to water. This research falls within 3 paradigms: the post-positivist, social constructivist, and transformative, which I'll discuss in just a minute. And it contributes to numerous theories: governance theory, critical political ecology, and urban political ecology, which focus more on narrative approaches and more critical perspectives of history. Foucauldian governmentality. Foucault focuses on power ideologies, where power is everywhere. It can be used to oppress or uplift. And the research process itself contributes, the results contribute to the construction of civic awareness and a form of strategic knowledge. And finally, discourse theory, which focuses on the discursive production and the production of power and the propagation of knowledge. I wanted to focus a bit on the different paradigms because of the audience today, being mostly science. Science falls within a positivist or post-positivist paradigm, where things are experimental and quantitative. You might have randomized controlled trials and things like that. Whereas more in your social sciences, you've got constructivist techniques. So these are ethnographic, qualitative, participatory action research falls within constructivist. Transformative, you're looking more at critical theories, participation, emancipatory practices, action research, human rights and equity focused research. Pragmatic is again participatory, mixed methods, and the latest paradigm, which has been in the making as of late, the indigenous paradigm, which is a culturally responsive post-colonial paradigm. This is a table similar to the previous one, both produced by Mertens 2024, and it's just been added on through the years, building on these different paradigms that we have. And I wanted to just point out my research, it falls within post-positivist, constructivist, and transformative. And transformative, it recognizes the various versions of reality and that are based on the social positioning. It has a conscious recognition of consequences and privileging other different versions of reality. Its epistemology is that knowledge is socially and historically situated, and research needs to address the issues of power and trust. Methods include qualitative and quantitative, can be mixed methods. and contextual and historical factors are described within the research. Moving into the literature review, this research addresses the 2030 Agenda for Sustainable Development goals that were developed presented in 2015. There are 17 goals, and this research aims to address at least 6 of them. Goal 6, to ensure the availability and sustainable management of water and sanitation for all, and emphasize the critical need to address governance and management of water. Goal 10, to reduce inequality within and among countries, and Goal 16, to promote or to provide access to justice for all and build effective, accountable, and inclusive institutions. Now, everyone is mostly familiar with the term government, and governance has come up more recently. And governance is not solely government. It is expanding to include the market and civil society. Loftus 2009, which was reiterated by Sutherland et al. 2015, stated that through an environmental justice framework, this social and political determination of how water should flow, through what technology and to whom, is critiqued as being unjust. So to address this unjust framework in relation to water, researchers began to look at the micropowers involved, the interplay of micropowers around the domain of water, to unravel the relations and better understand what was happening, and in order to increase transparency. Ratu and Veron, 2016, reiterates Foucault's position that the analysis of micropowers is not a question of scale or a question of sector. It's a question of point of view. In investigating power relations, weak ties are difficult to identify and tend to be informal. Stronger ties come when there is a similarity. Gautam Bhadra, 1985, urged that history should be revisited to understand the contingencies on which history hinges. Precht, 2016, provided some rich historical background within the Msunduzi municipality, particularly focus on environmental inequality, with a lot of focus on the greater of Edendale. And Pasanai, reiterated by Jewett et al. In 2019, stated that modernizing processes have little time or respect for indigenous knowledge practices or ways of knowing about water that have enabled indigenous people across Southern Africa to cope with health challenges. The South African context is haunted by a pattern of privilege and disadvantage. There's also been a delayed institutional establishment. Many of you are familiar with the delayed establishment of the catchment management agencies. And overlaid with this, you've got political complexities in the nature of dual governance structure, which was highlighted by Williams 2010. And he focused on the formation and integration of a dual governance structure within current democratic policies. This slide portrays the power cube, which was developed in 2006 by Gaventa, and it demonstrates the different dimensions of power, from levels to spaces and forms. On the left-hand side, you've got levels such as global, national, local, and spaces, which include closed, invited, claimed, and created, and the forms of power, which are visible, invisible, and hidden. Now, when thinking about power, researchers Hazra, Fletcher, and Wilkes in 2014 studied the tourism industry of Agra-India and came up with looking at resource-based power versus network-based power. Resource-based meaning having resources, and network is your placement within a network that would control the flow of those resources. So now that we've talked about governance as being more than just government, including civil society, and we've also discussed how there's a current and just framework within water governance, how do we look at the micropowers involved within water governance to determine a different point of view that we might not be seeing? Well, we can analyze the data. So for this research, we looked at various types of data, including archival material, government documents. Those included national policies, catchment management forum meeting minutes, full council meeting minutes, infrastructure portfolio committee meeting minutes of the local municipality, looked at academic literature, popular articles, and also analyzed GIS shapefiles provided by Msunduzi municipality. The analysis included a historical narrative approach to take a real critical look at history and write about the history from a different point of view. The additional data analysis was a bit more social constructivist. So you've got discourse analysis, content analysis, where you're analyzing a discourse. Then there was stakeholder mapping, which produced, which helped to identify stakeholders and determine relationships amongst the stakeholders. These could be collaborators, partners, funders. And lastly, more positivist approach, which would have been analyzing the GIS shapefiles and categorizing the different land ownership within the catchment as government, private, or trusts. So what has this research study resulted in? Through this work, we've been able to identify powerhouses that can be addressed to leverage change within the water governance landscape. The diagram on the top right is a stakeholder map of the Bainsbray catchment, a small catchment within the Msunduzi. And at the bottom, there is a circle which encompasses big business. Now, these stakeholders are not fully integrated into the conversations around water governance. However, they are active in the sense that they contribute, unfortunately, in a negative manner to the water quality issues that the catchment has. And that's just one example. There's others. Within the network, deep within the network, you'll find the UMNGENI Conservation Trust. And they've been a prominent player for positive change within the catchment. Secondly, we've identified missing or suppressed voices. The traditional authority has been highlighted as a stakeholder that could be more engaged. This has not always been an act that has been by choice. So it's allowing it, now that we have evidence of this, we can now address the situation and integrate these two forms of government that could, in a way that could impact water governance in a positive manner. Lastly, through this research, we've provided a voice to stakeholders that were previously disadvantaged, and in particular to vulnerable communities, such as those that live downstream, that use the water for drinking purposes. This concludes my presentation of research. I thank you for your time, and I look forward to further engagement around the topic of improved water governance in the Msunduzi catchment. Thank you.
Thanks very much, Susan. Certainly a change from the kind of topics I'm used to discussing. Maybe just opening the floor to questions. Susan, you are online, is that correct? Can you put your video on, Susan? I don't know if we have any questions for you. There we go. Got a question at the back.
Thank you, Susan, for your for your presentation. I'm Tando Ndlazi from UMNGENI Water. I have a few questions, 3 to be exact. So my first question is based on the stakeholder mapping, that's the exercise that you are doing. So I'm more interested on the Msunduzi catchment because I think most of us will understand that most of the issues in terms of E. coli, elevated E. coli levels that we find, we find ourselves struggling with at the Nanda Dam, mostly from the Msunduzi area and the town itself, and maybe the upper catchment of your 20H, Etendale area and other areas that are actually having issues of surcharging manholes in some pump stations, sewer pump stations that are not functional to the level that we will want them to be. So I'm trying to find out on your stakeholder mapping if you have looked at the UMNGENI Ecological Infrastructure Partnership. It's something that has been developed. I'm not sure if I'll say it is working to its full capacity, but I know that there are a lot of stakeholders there that are trying to pull resources together to work on water governance, water quality, and other issues. Another issue is the issue of coordination. Who gets to coordinate these water governance? I know that we do have water governance institutions like your DWS or CMAs, but in our case, we the Pongola to Umzimkulu CMA has just been is still finding its feet. So I'm trying to find out if you do have maybe someone from the CMA who can be a champion in terms of coordination of some of these activities, especially for the catchment. Thank you.
Thanks, Susan. Can you respond to those if you heard them clearly?
Okay, I just wanted to acknowledge the first question or comment. I am aware of the UMNGENI Ecological Infrastructure Partnership and have been involved with the UMNGENI Ecological Infrastructure Project, which is kind of where this research is stemming from. So thank you for that. I don't, if there was a more specific question about how to address these sorts of things, I didn't quite understand that part of the question. But as far as who gets to coordinate issues of this topic, yeah, I think ideally the catchment management agencies would fill a role such as that. But at the moment, those are still, the catchment management agencies are still forming and getting some footing. So I think that was part of why the UMNGENI Ecological Infrastructure Partnership came about, was because it was trying to fill that role until you've got a more established government structure to do such. I hope that answers your question. If I missed something, please feel free to comment further.
Thanks very much, Susan. I think we can put you in contact if necessary, so we can work on that. Thanks very much. So our next presentation is going to be done by Namira Ali, talking about standardized methods for analyzing emerging contaminants in wastewater to enhance, excuse me, water quality management.
Good day, everyone. As mentioned by the chair, my name is Namira Ali, and I'm a first-year PhD candidate at the University of KwaZulu-Natal, based at the Westville campus. Today, I am honored to present my project proposal, which was compiled under the supervision of Dr. BP Gumbi and Dr. S.T. Kesahan, for my research, which is titled Standardized Methods for Analyzing Emerging Contaminants in Wastewater to Enhance Water Quality Management. Okay, so let's begin with some background, right? As we all know, South Africa is considered to be a water-scarce country, attributed to its semi-arid climate and unpredictable rainfall patterns. Now, this is further highlighted by the country's global rank of being in the top 30th driest countries with a low of 450 millimeters of rainfall per annum in comparison to the global average of 860 millimeters. Now, with that being said, additional factors like population growth, urbanization, and industrialization, the country is currently experiencing a high consumer demand with limited water supply. Therefore, the government has now turned to the recycling of water by means of wastewater treatment as a sustainable means in replenishing its water resources for direct and indirect human use. Now, still, this approach brings its own set of challenges, the main being the presence of emerging contaminants in wastewater. So, emerging contaminants encompasses a diverse range of naturally occurring and synthetic compounds which are not regulated and persist in the environment, and they have the potential to have adverse physiological and environmental effects. Now, these contaminants include like pharmaceuticals, personal care products, and so on, as seen on the slide. Okay, so for this presentation, let's just consider pharmaceuticals, which is a major concern due to the environmental persistence. Now, medications like antibiotics, analgesics, antiretrovirals, all turn up in our country's affluent due to the population's medical needs. So, however, essentially all of these substances are designed to affect biological systems, and therefore they can remain biologically active in the environment and potentially impacting aquatic and human health, also degrading the quality of water. Now, the problem identified in this project is that most of South Africa's wastewater treatment plants primarily focus on the removal of organic matter, nutrients, and pathogens. And due to the diversity and unique nature of these contaminants, they often manage to slip through these plants. Therefore, in order to improve the efficiency of these plants and enhance water quality, management, it's necessary to develop methods to detect and investigate the fate of these emerging contaminants in our water systems. So it's a very challenging process to develop analytical methods to detect emerging contaminants firstly due to their low environmental persistence. So we turn to sample pre-cleanup and pre-concentration techniques to detect them at least subpart per trillion levels. Secondly, we also have to be able to detect not only the parent compounds, but their metabolites, their transformation products, and breakdown products, with each having its own unique chemical properties. Right? Therefore, the trend in literature shows that chromatographic techniques like liquid and gas chromatography are often used for accurately identifying and quantifying emerging contaminants in wastewater. Now, these methods can effectively separate complex chemical mixtures based on their volatility, their polarity, and their molecular weight, with high precision and sensitive detection. Now, in literature, we often see these techniques coupled to mass spectroscopy, which significantly enhances the method's overall sensitivity and specificity. Now, standardizing these methods for emerging contaminants is crucial for ensuring consistent, reproducible, and comparative results across different studies and locations, which would streamline the detection process and provide reliable data to help regulatory agencies effectively manage water quality. So this research is motivated by its potential to significantly influence policy changes and regulatory frameworks related to water quality management in South Africa. Now, the development and standardization of these analytical methods for emerging contaminants will enable wastewater treatment facilities to adopt more advanced technologies to tailor to specific contaminants. So this study holds great promise in contributing to water scarcity, environmental protection, and the sustainable management of water resources in South Africa. So this brings us to the aim of this project, which is basically to develop and standardize analytical methods for the detection and quantification of emerging contaminants in South Africans' wastewater systems. Now, in order to achieve this aim, Firstly, we would need to identify class representatives of emerging contaminants of concern within South Africa's water sources by means of literature search and preliminary non-target studies. Secondly, we would develop and validate chromatographic methods which would ideally analyze several classes of compounds using a single method. Third, we would be by the application of this developed methods by investigating its robustness, reproducibility, and applicability to the complex wastewaters matrix. And lastly, to compare newly standardized methods with the approaches used in developed countries. By seeing how South Africa's methods measure up to global practices, this research aims to figure out where South Africa's current methods can be improved. So let's have a look at existing, some recently published literature, as seen here on table 1. So we have 4 recent studies on the development of analytical methods for emerging contaminants, pharmaceuticals, endocrine disruptors, personal care products, and pesticides, which was done in Japan, China, Germany, and South Africa, respectively, right? From this, we see that the detection of emerging contaminants is still relevant in developed countries as in developing countries. Now, as a tangent to this, a review conducted by Salwa et al. Showed in 2022 concluded that the level of research conducted on method development for these emerging contaminants in South Africa is significantly further along than other developing countries in the Southern African region, right? So looking back to the table, in these studies, if we consider the sample preparation, right, which importance was spoken on earlier, solid phase extraction, was used, which is in keeping with majority of emerging contaminants studies, where HLB cartridges were used for solid phase extraction of wastewater samples, promising an effective sample cleanup and pre-concentration. Next, these studies utilized chromatography, coupled to mass spec, which further emphasizes what was said earlier, that this technique coupling enhances the sensitivity of the detection, which is also highlighted by the concentration range, right? The subparts per trillion detection range. Thus, we propose the use of solid phase extraction for sample preparation and chromatography coupled to mass spectroscopy for the analysis of various classes of emerging contaminants in wastewater. So let's progress to the sampling area, right? So we proposed the KwaMashu wastewater treatment plant where we conducted our preliminary studies. From the observations of the surrounding areas, we see a residential area, adjacent industrial areas, as well as hospitals in the vicinity. So this should accurately provide an excellent representation of the emerging contaminants used by at least this province's population entering the plant via the inlet. And this would provide the assessment of the efficiency of the plant in the removal of these emerging contaminants based on the major treatment points, right? So therefore, 5 sampling points were identified: the inlet, the primary settling tank, the activated sludge, the secondary effluent, and the outfluent. Now, in terms of the experimental protocol, the samples were collected using a stainless steel bucket into amber glass bottles, where it was placed in an ice bath for transportation. And lastly, upon reaching the lab, it was stored in the fridge until further use. Now, for the proposed analytical or experimental protocol for sample analysis, the first thing to be done was filtering of the sample to remove any solids or biosolids from the water. The next step would be sample preparation, where we'll use solid phase extraction using HLB cartridges. So using a vacuum manifold, the process starts with conditioning of the cartridge and equilibrating the cartridge, followed by loading the cartridge with the sample. We propose a minimum of 500 ml of sample. Then cartridge would need to be dried. Finally, the elution of the retained compounds in the cartridge, right? So the next step would involve allowing the eluate to dry, removing any solvent before reconstituting Okay, and at this stage, we may need to use a derivatizing agent. Finally, the sample is ready for chromatographic analysis, which would be coupled to mass spec, right? At this stage, or at method development of the analytical protocol, right, we would need to investigate parameters like the mobile phase, type and volume of sample injection, flow rate, and so on, in order to see good analyte separation. Now, so moving on to method validation of these protocols, right? We need to ensure that it would be suitable for its intended use. So we assess the method's parameters, such as the limit of detection and quantification of each analyte, the line of regression, and recovery studies. This means that the protocol delivers dependable results and meets regulatory standards for accuracy and reliability. Now, for the standardization of the method, it would be more critically intensive when ensuring data reproducibility. So basically, this means that we would need to do testing across labs, as well as an in-depth compilation of sample preparation, method analysis, and reporting. Now, this would allow for further comparison of data across studies and regions when using this method. So currently, I'm working on finalizing my literature review and conducting preliminary sampling and their screening to confirm and identify detected classes of emerging contaminants in wastewater. Next, I will be proceeding to method development for pharmaceuticals using chromatography, and then conducting sampling for validating and applying that developed method. To conclude, this proposed project is aimed for standardizing of chromatographic methods to detect and quantify emerging contaminants in South Africa's wastewater. This work has the potential to play a significant role in supporting sustainable water quality management in the country. Looking ahead, there is a potential for this project to lay groundwork for further research to refine quality standards both nationally and internationally. Finally, I would like to pay special thanks to the academic support provided from my supervisors, Dr. Gumbi and Dr. Getahau, and the EnviroSenses Research Group, as well as thank the WASH and R&D Center and the Department of Water and Sanitation, and special thanks to the UMNGENI UTHUKELA Water for funding this research, the University of KwaZulu-Natal for the infrastructure and facilities provided to conduct my studies, and lastly, Press 24 and UMNGENI UTHUKELA Water for providing the means to present my research today. Thank you.
Thank you very much, Nemira. Are there any comments or questions? It was nice to see your literature review and your proposed methodology.
It's your first year?
Yeah,
Okay.
my first semester.
First semester,
Yeah.
okay. It would be nicer if we could then engage further.
Okay.
Yeah, thanks.
Okay.
I think for selfish reasons, I would have loved this to be expanded to double Dr. Samuel, and you will understand the reasons why. Because of the wastewater reuse that's underway there. So we do need to understand exactly what sort of emerging contaminants you can pick up from that wastewater treated water. Thank you. Reused water. Thank you.
Yeah, good presentation. You have good presentation. We know that this is your first semester. Which antibiotic are you looking at?
I think we're going to be looking at all classes of emerging contaminants. At this stage, we will still be, we're still in the process of identifying which ones in South Africa are of a concern. And I think we'll be using a combination of literature to provide us with that, as well as preliminary studies using like non-target experimental procedures. Yeah.
Okay. So the reason why I asked this one is you mentioned that the standardization of this analytical method. What we see that the chromatography mass spectrometry is a standard method. Are you looking at detecting the parental component and the byproducts as well. All right, so I think it's too early for you to answer. This method would give you the total, if I am not mistaken.
Yeah.
How would you detect, differentiate between the byproduct and the parental?
I understand your question, but I think at this point in... Yeah.
I don't think there is anything you can do on the methodology of an instrument. But I think once the first thing first, she has identified what is currently available, and then she will identify what is unknown from what is known. And then theirs will be the contaminant that is going to be working on. Then she will have to slightly change the topic because she can't optimize the procedure. Yes. Thanks. No, but as a first year, it's fine.
Thank you.
It looks like your supervisor should be helping you out.
I think slightly expanding on that, I think it would be also nice, Dr. Samuel, to look at the influence that goes into that wastewater reuse plant. So that we can know exactly what sort of emerging contaminants are getting into the potable reuse plant. Then after treatment, what are we getting? Are we removing any of those emerging contaminants as they come in through the treatment system? Thank you.
Thanks very much, Namira.
Thank you.
I'd like to move on to our next presentation, which is also going to be a video clip, which is going to be presented by Lawyer Dunn.
Hello, everyone.
Okay.
Hello, everyone. My name is Oyeladun Roda Adegoke. I welcome you all to my talk, which I titled Absorption of Sodium Hexaxole onto Biochar Graphene Oxide Composite, supervised by Professor Bishri Machinchin and Professor Vincent Yamori. The presence of antibiotics in AKL's body as one class of emerging pollutant is a worldwide issue because it can lead to antibiotics resistance gene. Hexaxole, which I denoted as XMX, is an antibiotic used by human and for veterinary application to treat bacterial infection, such as urinary tract infection, middle-ear infection, prostatitis, and bronchitis. Due to incomplete metabolism, roughly 30% of the substance is excreted in its original pharmaceutically active state. And also due to the lack of effective treatment technology for XMX removal, XMX has been detected in low to high concentration in manure, wastewater, surface water, and groundwater of different countries. The concentration of XMX detected in wastewater in South Africa is between 7.93 to 35.4 microgram per liter. So since the presence of residual XMX and its metabolites may lead to formation of pathogen strain resistance to antibiotics, thereby endangering human health, there is a need for effective method for the removal of XMX in wastewater. Absorption, among other remediation methods, has been identified as a fast and easy method of treatment that helps to overcome this growing threat because of its simplicity, cost effectiveness, and easy for regeneration and reutilization. The process of absorption involves the use of adsorbent. Some of the adsorbents that has been used for absorption include activated carbon, carbon nanotube, and so on. But for this study, we are using biochar and graphene oxide and their composites for the removal of XMX in aqueous solution. So what is biochar? Biochar is a stable carbon material that can be obtained through heating of biomass thermally and hydrothermally in the presence of little or no oxygen, and is known for the unique merits such as low cost and renewable. It also has its limit, which is low absorption capacity. Graphene oxide, on the other hand, is a single monomolecular layer of graphene with various oxygen functionalities. It also contains some of the merits which include high absorption capacity and excellent thermal stability. Also, it has its limitation which are poor dispersion and agglomeration in aqueous solution. So, the composite is made to overcome individual limitation faced by biochar and graphene oxide respectively. This leads to aim and objective of this study, which include to investigate the ability of graphene oxide composites to absorb XMX, and the objectives are to establish a quantification method for XMS, to study the influence of pH, contact time, absorbent dose, initial concentration, and temperature, and also to establish the absorption mechanism of XMS. Data from two different biomass material were used in this study, which are pine pellet and exotic plant material. And the biomass were pyrolyzed and high temperature, grinded, and ball milled to fine powder. Also, graphene oxide was synthesized using improved Omer method by adding onto graphite sulfuric acid and phosphoric acid in the ratio of 9:1, and potassium permanganate as an oxidizing agent was added slowly at low temperature, and it was stirred for 5 hours in ice water, and hydrogen peroxide was also added to stop the reaction. 5% hydrochloric acid was later added to wash the resulting solution so as to remove the sulfate that must have attached to the surface of the material, and then washed it with deionized water and put the washed solution in the dialysis tube and continue washing until a pH or a neutral pH was recorded. Biochar graphene oxide was prepared by mechanomixing biochar and graphene oxide at different composition, and by varying the amount of biochar while the amount of GO remained constant. UV spectrophotometer was used to quantify the amount of XMX absorbed. Figure 4 shows the UV spectrum of XMX at 10 mg per liter. Figure 5 shows the calibration curve for XMX, the regression of 1, and also the equation at the concentration of 1.3996 to 18 mg per liter with the regression of 1 and the equation of the graph which obeys the Beer-Lambert law. Part of the parameter conducted is effect of pH. Absorption study at different pH value is a way to investigate the surface chemical effects of absorption on adsorbate onto adsorbent. It is a very important factor that affects suction behavior at the liquid to solid interface and speciation. Figure 6 shows the effects on the absorption of XMX onto all the biochar composites, including the pristine material and also the GO. And the pH range is from 2 to 10. From the structure of supermethoxazole that we have here, we can see that the supermethoxazole structure has pKa value of 1.57 at the amide group, and also at the amide group the pKa value of 5.7. At acidic pH, which is the amide group, the XMX was dominated with neutral species, and in relating this with the pH PZZ value of the adsorbent, the adsorbent was positively charged at the pH less than the value of pH ZZ, but negatively charged at the pH greater than the pH-PZC value. So the attraction between the adsorbents for all the adsorbents and XMX was due to a hydrophobic effect and pi-to-pi interaction, which is shown by the higher percentage removal observed at pH 2, which is the optimum pH for all the adsorbents. So it's observed that as the pH increases, there is decrease in the percentage removal. The influence of varying the contact time on the adsorption is done so as to know the time which equilibrium will be attained. Figure 7 shows the effect of contact time on the adsorption of XMS onto whole batch of graphene oxide composite, with the time ranges from 5 to 1,440 minutes. The result shows that the increase in removal efficiency as the contact time increases. Also, the equilibrium was attained at 180 minutes for all the adsorbents, and also at also steady increased removal efficiency was observed due to availability of more active sites at the initial stage. Also, effect of dosage is part of the important parameter to be investigated in adsorption study. The result of effect of dosage in figure 8 shows that as an increase in the percentage removal was observed as the mass was increased, which is due to the large surface area at a number of more exchangeable sites at fixed concentration. As well, we also need to know the initial concentration of XMX that can be absorbed. So the effects of initial concentration was carried out. The concentration varied was between 1 to 10 milligram per liter, and the result shown in figure 9 shows that as absorption capacity was increased as the concentration is being increased, because at higher concentration there is an effective driving force that induced to conquer the mass transfer resistance of adsorbate on the adsorbent to adsorbate interface. Temperature is also one of the major factors which affect the absorption of pollutant onto adsorbent, and it has to be considered. The results revealed in figure 10 shows the temperature that was varied, which is between 25 to 40 degrees Celsius. It was observed that there is no significant change as the temperature changes and for all the adsorbent, which suggests an endothermic adsorption process. In order to know the type of interaction that occur between the adsorbent and adsorbate, and for quantitative measurement of absorption capacity, there is a need to study the isotherm model. In this study, equilibrium data from effect of temperature at varied concentration was imputed into RStudio statistical computing environment, which is a non-linear least square analysis, to fit into 2 and 3 parameter isotherm model, which include Langmuir, Friedrich, Temkin, Todd, and so on. And sum of square residue was used to evaluate the best fit. The smaller the sum of square residue, the better the fit. Table 2 shows the best two that has the least sum of square residue value, which are Langmuir and Friedrich. And out of the two, Friedrich shows the best describe the absorption of XMS onto all the adsorbents, which means absorption took place at the surface of the adsorbent, which depicts heterogeneous interaction. Absorption kinetics were done to ascertain and to evaluate the absorption rate and mechanism, such as diversion, control, and mass transfer. It also identified limiting steps involved in absorption process. In this study, the data obtained from the effects of contact time was imputed into a non-linear least square analysis to fit 4 kinetics models, which are pseudo first order, pseudo second order, Elovich, and intraparticle diversion. The sum of square residual was used to evaluate the best fit. The smaller the sum of square residual, the better the fit. Table 4 shows the best two that has the least sum of square residual value, which are studio first order and studio second order. And out of the two, studio second order describe best the absorption of sulfamethoxazole onto all the adsorbents used, which indicates a biomolecular process, which is chemisorption. Table 5 shows the absorption capacity of the material, the adsorbents used in this study, as it was compared with other that has been used in the literature. Although some of the results obtained in the previous study were greater, the result obtained is still favorable compared with other reported. One of the major advantage of absorption over other remediation method is the ability to reuse the material over another process again. So in this study, we perform 4 cycles of absorption-desorption experiment, and it shows that the material can be regenerated and reused. Finally, we can conclude that the optimum pH for XMX is established at 2. Equilibrium was reached at 180 minutes, and that studio second order best describes the absorption for all the material used. Friedrich isotherm also described for all the adsorbents used, and of all the adsorbents, fine pellet biochar graphene oxide composites had the highest absorption capacity at 78.2 milligram per gram. And also the generation of adsorbents with the use of methanol shows good efficiency for all the adsorbents. I would like to appreciate my supervisor for their support, the UMNGENI Water for Funding, Water Research Commission, REWA, Nanochemistry Research Group, and Almighty God. Thank you all for listening.
Thank you very much for that. Unfortunately, she's not online, and Prof. Martinsig was going to try and join us, but I think she might have got held up. I don't see her here. So I'm not sure, are there any questions or well, nobody here to answer questions, but are there any comments? I don't see any. Nothing online. Okay. Can we then move on to our next presentation, which again is going to be a video clip by Relabukile Morake on the evaluation of biochar and activated carbon produced from different feedstocks for use as an absorbent.
Good day. My name is Relabukile Morake, and I'll be presenting my project on the evaluation of biochar and activated carbon produced from different feedstock for the removal of pharmaceutical compounds found mainly in decentralized wastewater systems. An alarming number of people are currently facing water scarcity. This is due to many factors, including contamination of our water systems. There's been a high number of occurrences of contaminants of emerging concerns, which we refer to as CECs, that are being detected in wastewater effluents. So CECs are a group of compounds that are either man-made or natural. They range from pharmaceuticals, personal care products, cleaning material, as well as antibiotic-resistant bacteria. For the context of my project, I'll only be focused on pharmaceuticals. Pharmaceuticals enter our environment through various pathways, such as improper disposal from industries like our car manufacturers, hospitals, or even households. These CECs can travel through wastewater all the way to the food and the water we consume. They pose a great risk to humans and the environment. There's been a few reports that have said to cause decline in coral reefs and sex change in some fish. An interesting fact is that our bodies are also only able to metabolize approximately 60% of these pharmaceutical compounds. So that means the remainder is excreted and ends up in wastewater treatment plants. Unfortunately for us, conventional and unconventional wastewater treatment plants are unable to completely remove these compounds. Therefore, they are usually found at ultra trace levels, making detection as well as the removal of these compounds extremely difficult. This has led to a great interest in developing sustainable methods to remove these from our wastewater treatment plants completely. And at the forefront of these studies is using absorption as a mechanism to remove pharmaceutical compounds from wastewater. When we talk about unconventional wastewater treatment systems, we refer to technologies such as a decentralized wastewater system, which we refer to as DWATs. So DWATs are different from our conventional wastewater treatment plants as they are off-grid. They also function at a smaller scale compared to our conventional wastewater treatment systems. They use natural resources such as anaerobic processes, while our conventional wastewater treatment plants uses complex and extensive processes such as reverse osmosis, advanced oxidation, as well as using membrane filtration. There are a couple of advantages of using this kind of system as it allows for low energy, it's also cost effective, and allows water reuse. The wastewater which we'll be treating in our project is from a DWATS located in Newlands, Mashu, which services 83 households. So my project forms part of a much bigger project. We collaborated with Umia University in Sweden, as well as Mohammed V University based in Morocco. The project aims to develop an efficient wastewater treatment methodology with low environmental impact. The project is divided into 4 work packages. So work package 1 focuses on the removal of pharmaceuticals using activated carbon and biochar. This is where my project is based. The second work package is the thermal destruction of the synthesized carbonaceous material. The third work package is focused on the acceptance of wastewater reuse. And work package 4 is implementation of these said methodologies. My project focuses on the production and generation of biochar and activated carbon from readily available material. We chose this material based on the fact that black wattle is an alien invasive species, and horse manure due to the number of equestrians around KZN, and eucalyptus as well because of its abundance in the area. We also aim to understand the physiochemical properties of the material and also test its absorption capacity. Below is a depiction of what an activated carbon surface or the activated carbon would look like. It's quite a porous structure allowing for removal of contaminants. I'd like to compare it to a sponge of some sort with a very heterogeneous surface with different pore volumes and pore structures. Three different feedstock were chosen, like mentioned in the previous slide, which were eucalyptus, black wattle, and horse manure. These feedstocks were pyrolyzed at 2 different temperatures, 350 and 700 degrees Celsius. The biochar that was generated from the feedstock was then chemically activated using potassium hydroxide as well as phosphoric acid. The biochar and activated carbon were then characterized using different characterization methods, and the absorption capacity was evaluated using tartazine dye as a proxy instead of pharmaceuticals. The graph demonstrates the percentage yield of different feedstock at different pyrolysis temperature. The dark green represents that at 350 degrees Celsius, while the light green represents at 700 degrees Celsius. So the pyrolysis temperature is one of the many factors that influences the physiochemical properties of biochar. So the pyrolysis temperature can affect several properties such as the stability, the topographical structures, as well as the functional groups that are available on the biochar. So the results show that a yield of biochar produced from different feedstock is greatly affected by this pyrolysis temperature. The decrease in yield at higher temperatures is due to thermal breakdown as well as release of volatile matter at high temperatures. So the percentage yield of wood-based biochar is greater than that of the manure-based biochar, and this can be attributed to the components that make up certain feedstock. So wood-based biochar has a greater lignocellulistic composition than manure-based biochar. This would then result in wood-based biochar producing more solid structures and are often regarded more thermally stable than manure-based biochar. From the proximate analysis results, we can deduce that increase in pyrolysis temperature increased the ash content as well as the fixed carbon, but decreased the volatile matter. And from these results, we can also see that horse manure had the highest ash content. And like the previous slide, this is due to the composition of horse manure. Wood-derived biochar for both eucalyptus as well as black wattle had the highest fixed carbon, and this is due to the lignocellulistic composition as mentioned before. So these results then corroborate the percentage yield results as well as the percentage yield of activation. One of the many factors that influence the absorption capacity of a material is the surface area. So we also investigated the surface area of the three feedstock using BET analysis. And what we see highlighted in red is that the surface area of the biochar at 350 degrees was extremely low compared to that at 700 degrees. This means that an increase in pyrolysis temperature had a positive impact on the surface area as well as the pore volume. However, when we look at the activated carbons, there wasn't a huge increase in the surface area between the two temperatures. This means that activation has a positive impact on the surface area as well as the pore volume of material. The highest obtained surface area was when we used potassium hydroxide at 700 degrees Celsius. These show the micrograph structures of the activated carbon and biochar of eucalyptus. An increase in temperature resulted in pores of different structures. Chemical activation led to the destruction of the walls, which led to a more heterogeneous surface, which would allow for a greater surface area or active sites for adsorption to take place. We also noted a few crystals on the surface of the eucalyptus and these may be due to the activating agents that were used. We also looked at the thermal stability of the activated carbon, the raw material, as well as the biochar. We can see that an increase in pyrolysis temperature and activation resulted in a more stable material as compared to the raw material, as there's almost a 40% weight loss in the raw horse manure material, and all the other biochar and activated carbon had nothing more than 40% of their weight loss. The most stable structures were for acid activated carbon at 700 degrees Celsius. And this was the common trend that was seen amongst all the other feedstocks. The same was observed for the black wattle. Biochar had the highest absorption.
Looks like we're having some problems there. It wasn't recorded very well. Shall we stop it there?
When we compared it to the activated carbon.
Unfortunately. So again, I don't think she's online. I'm not, Dr. Sebastian Stringel was going to be online to answer questions. I don't know if... Sebastian, okay, thank you. Can we open the floor to questions then? Looks like you got an easy one.
Hi, Jeff.
Hi, you, Sebastian. Good, thanks.
Hello,
No
everybody.
questions or comments?
Sorry, I just wanted to ask, the application is still at the lab scale, or you already moved to a field work?
Well, the project is finished, and because of COVID and lack of time, we couldn't arrive to the field, so we have to close the project in the laboratory. However, the very interesting part of the project was done at UMIA University, and with the biochar that we're producing here, we send them there, but because they have the capabilities to measure pharmaceutical compounds, they measure the absorption capabilities of each of the biomass in Morocco and South Africa, which were 6 in total, different activated or non-activated, pyrolyzed at high temperature, low temperature, and they make a matrix of the absorptions of 120 compounds of pharmaceutical emerging pharmaceutical compounds, and thanks to this data that is there, that's the conclusion of the project. And the important and interesting thing is that the biochar produced at high temperature was very good was very performant to absorb pharmaceutical compounds, which means that you don't have to activate them, which is a very good news in point of view techno-economical, because activation is expensive. So if you can just do the biochar. So we have very interesting conclusions. Now we are just wrapping up the project, because now it's the end of the project. We have to send a report. It was the big project, we have funding to support the local work at UKZN with the UMNGENI waters. Thank you very much. But the big project was funded by the Swedish Research Council, that side, and we have to submit all the papers and everything at the end of this month. So we couldn't draft the work package for was application in the field in DWATS. We wanted to apply. Really, we have a DWATS plant in KwaMashu. We wanted to apply this, make this with the conditions, the best biomass that we find, and the most suitable biomass and the most suitable conditions of preparation that we saw in the laboratory. We wanted to do it there, but unfortunately, between COVID and all the administrative things and that researchers always has, we couldn't do it.
Thank you very much. Looks like there are quite a few more questions coming up. Maybe we'll take just 2 questions.
Thank you so much. I wanted to find out, you were talking about pharmaceuticals. What type of pharmaceuticals particularly and specifically, and if they're antibiotics, what type of antibiotics, but just so we know what this can really work with.
Well, it was, the 120 was done in Umeå University in Sweden. Because they have the GCMS, MS equipment, and they have also all the expertise and experts in the measurements of these types of analysis. I don't know I think I don't know is the pharmaceuticals they studied. However, what I can tell you is that the pharmaceuticals were based in a previous study of that same group that was done in collaboration with my research group, the Washardi Center, and UKZN. They did like many years ago, maybe 5 years ago, 5, 6, 7 years ago, they measure in the DWATS plant in KwaMashu, they measure the composition in pharmaceutical compounds. They screen and they make a comprehensive analysis of pharmaceutical compounds. That and data from Morocco, because also the other part of the project application is Morocco. They based on those these real data sets of pharmaceutical compounds that were analyzed before. They did a test in UMEA, but I don't have the memory to memorize the 120.
Yeah. Okay, thank you, Dr. Santiago. I really appreciate this work, but my question was, considering that those results we have got with strict temperatures like 700 degrees, following up on the first question, in terms of scaling up, are there any plans to have a pyrolysis plant or something that can yield this bigger biochar quantities? Because when you're looking at the DWATs, it's a lot of water that goes out of there and we need a lot of biochar. Are there plans that are in place to maybe pyrolyze biochar at scale? And looking at the energy crisis, is electricity feasible, or are there collaborations with mechanical engineers as to making kilns that can pyrolyze, and also seeing how that deviates from the fixed temperature of 700 degrees, looking at that when you're using a kiln, you can't control temperature that much?
Okay, thank you very much, Kobile, for your question. First of all, a small precision. Yes, well, pyrolysis can be just a small detail. Pyrolysis can be exothermic. Well, can be endothermic, exothermic, or autothermic. Like depends of the condition. So sometimes you just have to bring the initial energy, and then the reaction will sustain it by itself. But yes, to answer your question, and as told him, because of many unforeseen circumstances like COVID, we couldn't make the work package 4, which were this work package 4 was the one to apply in the field that. So we have to see when at the middle of the project we we see that we're not going to have the time to do it, and we prefer to focus on the lab work. So we even not think what are solutions for the production in the big scale of the biochar. But, however, at the beginning of the project, at initial stages, we were thinking to find a place where they produce charcoal, for example, for rice or whatever. For example, there is a many by Pietermaritzburg. There are 2 or 3 or 4 like producers of charcoal for rice. We were discussing with these guys if we could how we could collaborate, and maybe they can help us to produce our biochars. And also the other option we saw that is that there was a project here in Durban, very interesting project about indigenous plant, the wattle. So they were cutting wattle that is indigenous. It's an alien invasive plant. So they're cutting it, and there was this like NGO or this initiative, I would say this venture, they was trying to make biochar with this like a very rudimentary way to do biochar with kilns and fire, etc., etc. So we also were discussing with them. But these discussions were abandoned when we see they were never going to arrive to work package farm. Okay.
Thanks very much. I think on that note, let's wrap up and move on to our next video clip, unfortunately, or fortunately. So our next video clip is by Akhil Ramlakhan, but he's going to be talking about the development of solar thermal drying technologies for the treatment of sludge.
Good day to all. My name is Akhil Ramlakhan, and my presentation is on the testing of a screw conveyor solar sludge dryer system. Firstly, a bit of background on the project, starting off with what exactly is fecal sludge. Fecal sludge is the waste which accumulates within on-site sanitation systems, such as pit latrines or septic tanks. In a normal fecal sludge management system, as can be seen on the slide, the sludge is collected, after which it is transported to a treatment facility where it's treated and pasteurized, after which it's either disposed of or reused. The image on the slide shows it being used as a fertilizer. Even though in our current world most people have access to sanitation facilities and the number of people who have access to these facilities is growing all the time, there are still in excess of 2 billion people that live without access to proper sanitation. A lack of proper sanitation can have many side effects, ranging from something as benign as an offending smell to something as serious as outbreaks of deadly disease, such as cholera through contamination of water supplies and the soil used for growing food. One of the possible methods for the treatment of fecal sludge is through thermal drying, as this has the effect of both pasteurizing the sludge by holding it at elevated temperatures for extended periods of time, but also reducing the weight and volume by the removal of bulk water. The issue with a thermal drying approach is that thermal drying is expensive, both in terms of the equipment necessary, but also in terms of the energy required to liberate the moisture from within the sludge. This makes thermal drying in its traditional form unviable for smaller communities, as the cost of equipment and the running costs may be very, very high. A possible solution to this elevated cost is using a solar thermal system, as Southern Africa possesses some of the highest amounts of solar thermal energy in the world, which provides a plentiful and renewable energy source. This project involves the testing of a device that uses an alternative and renewable energy solution in order to largely reduce the energy consumption during the process of thermal drying of fecal sludge for sanitation purposes. The screw conveyor-based sludge dryer comprises of 3 main subsystems, namely a solar air heater, a reflector subsystem, and the screw conveyor drying chamber itself. The solar air heater is a fairly standard flat-plate solar collector with an absorber plate size of 1 meter by half a meter. The enclosure is unique in that the sidewalls are also transparent to ensure that as much of the solar irradiance enters the drying chamber at a time. This subsystem may be used either with or without a dehumidifier in order to additionally dry the air prior to entering the drying chamber. The baffle design is also unique, as this was designed to allow for the utmost time in contact with the absorber plate while also increasing turbulence in the airstream. The baffle design may be seen on this slide. Next up is the screw conveyor drying chamber, which has been modified in 2 key ways from a normal screw conveyor. Firstly, the truck utilized is transparent and cylindrical, as opposed to being metallic and U-shaped. Secondly, the auger used is shaftless. This allows for better conveyance of sticky materials such as fecal sludge. This subsystem both mixes and agitates the feedstock as it passes through the drying chamber. The transparent sidewalls allows for the ingress of both sunlight from the ambient irradiance and the irradiance from the reflectors. The reflector subsystem consists of a singular large linear parabolic reflector, as well as two smaller flat plate reflectors. The linear parabolic reflector provides the majority of the solar energy into the drying chamber, and the flat plate reflectors simply supplement this. The device testing took place in 3 phases. Firstly, functionality testing, which ensured that all of the subsystems functioned well together, as well as in conjunction with the other subsystems. The second phase included testing using wetted soil, and this phase was used to find ideal device settings. The final phase used synthetic fecal sludge as an analog for the waste collected from on-site sanitation facilities. This phase tested the device's overall drying capacity with sludge. All tests recorded temperature, humidity, solar irradiance, and power consumption in order to determine a suite of key performance values. Looking at the wetted soil testing first, and as mentioned, this phase was envisioned to determine the ideal device settings. This was undertaken in 2 phases. Firstly, the testing of the ideal device configuration by systematically removing a single subsystem per test in order to determine if any provided a large amount of performance or if any were detrimental to performance. Next, the ventilation settings were found by testing various airflow rates within the device in drying tests. Looking at the performance data captured from these tests, we tended to find no real performance detriment or benefit when removing the various subsystems when we looked at the drying rate and the efficiency values. The SEC values, however, when the dehumidifier was removed, was significantly lower than any of the other scenarios. It was therefore chosen that the dehumidifier would not be utilized for future testing scenarios. We also found no real performance change when the ventilation rates were changed. As such, the lowest ventilation rate was chosen, as this would result in favorable energy consumption when the device was scaled up. Next up, we'll take a look at final testing. This testing was mostly focused on determining how the device functioned when the initial moisture content values were varied. This was done by running drying tests while varying the initial feedstock moisture content. This provided drying curves for material at 80%, 65%, and 50% initial moisture content. The additives were envisioned to do different things to the feedstock. Slaked lime was used to aid in the sterilization of the fecal sludge. Activated carbon was envisioned to provide a darker material that could absorb more energy in theory, and the sawdust was chosen to allow for formation of vapor passages within the feedstock during the drying process. On the current slide, we can see an example of the drying curves for the varying initial moisture content tests. The first one on the right starts off at about 80%, and the one on the left in green starts off at around 50%, and these show the performance of the dryer throughout the various moisture content states. And lastly, we can see the results obtained during the final testing phase. We tended to see that the higher the moisture content of the feedstock was, the higher the overall drying rates and efficiency values. This tended to show that even though the performance values were lower with the lower moisture content sludge, the device was still capable of functioning at these conditions. When looking at the performance of the dryer when using the additives, the performance was very similar in all cases, and they did not appear to provide benefit to the drying performance. However, the slaked lime did provide an improvement to the texture and stickiness of the feedstock. From the testing of the screw conveyor solar sludge dryer, the following conclusions were made. The dehumidifier consumed too much power to be utilized in the device. Removing it reduced the SEC by over 2/3. Varying the ventilation rate resulted in similar performance. As such, the lowest rate, which would result in the lowest power consumption, was used. The dryer performs better with higher moisture content feedstock, but was capable of drying the feedstock to a final value of 32% moisture content when it started at 50. The additives did not appear to have any bearing on performance, but the slaked lime did provide a better texture, making the conveyance of the feedstock much easier. Overall, the testing of the device has shown that the screw conveyor-based solar sludge drying system has promising performance and the potential to provide a station system which runs on abundant and renewable energy in the form of solar thermal energy. Thank you so much for your time, and I'd like to thank the following people for making this project possible. First of all, the Water Research Commission. Second of all, the WASH R&D Center and all of the staff. And lastly, my supervisor, Dr. Santiago Seki.
Thank you very much for that presentation. I don't think Kil's online, but again, Santiago is here to answer questions if anybody has any questions. No questions? You're lucky let off.
No questions.
Thanks.
Okay.
Thanks very much. Okay, starting to wrap up. 2 more presentations to go. I think all the other sessions are finished, I believe. Looks like the engineering is finished, so we'll wrap up. The next presentation is going to be on the development of a urine evaporator for innovative non-sewage sanitation systems, and it's going to be presented by Dr. John Pocock on behalf of Kirti Rampasad.
Okay. Thank you. I'm here to present on behalf of Kirti. I was hoping that her co-supervisor, Santiago, would be able to present, but I didn't even realize he was going to be here. So this is about the development of a urine evaporator, which has been ongoing for the last couple of years at the Wash Centre at UKZN. And it involved a number of students from a final year mechanical engineering project as well, who should also be credited, and Dr. Glenn Campbell-Snedden from mechanical engineering on development of the actual evaporator itself. Oh, clicker, okay. Okay. So the reason why we're interested in urine is that obviously it has a lot of nutrients in it and can also be used as a fertilizer. The unfortunate part of it is that obviously in a non-sewage sanitation system, it has a very high volume for the amount of actual nutrients that are in there. But for example, nitrates, phosphates and potassium, very important in fertilizers, and we can actually concentrate the urine, we can actually gain a valuable product which can be used as a fertilizer, but doesn't have the bulk of having to transport large amounts of urine around. So although it's energy intensive, we can achieve this at lower temperatures if we're using a good evaporator with airflow and high mass transfer rates. And we can end up with a fertilizer which hopefully won't be too energy intensive to actually produce and would be a saleable product. So what Kirti focused on initially was the collection and analysis of urine itself as it is evaporated, as the water content is removed. So it started with 2 sets of collections of different urine. One was the fresh urine, which was collected within the Wash R&D Centre from volunteers. And the second was hydrolyzed urine, which was obtained from the taxi rank at Asie Etafuleni, sorry about my pronunciation, which obviously has been in situ for some time. It's collected in larger tanks, etc. So it has hydrolyzed already. So there's a lot of ammonia coming out of it, apart from anything else. The samples of the different urines, both the hydrolyzed and the fresh, which was then stabilized by addition of lime, were evaporated in the oven at appropriate temperatures, and samples were extracted to look at the way that the properties of the urine evolved over time, in other words, with the concentration of the urine as well. The reason for doing this is that obviously when we're looking at an evaporator itself, we want to know what the properties of the material that's being evaporated are as the water is being removed. So we were worried about things like, would we end up destroying all the carbohydrates in there? Would we end up removing too much water and end up with crystallizing the urine out, etc.? And would we have precipitation, etc., etc.? So we looked at the evolution of pH, the evolution of electrical conductivity, the water activity, which gives us an idea of whether or not bugs can live in there, and also the amount of water that's freely available. Thermal conductivity as well, because obviously when we're heating something, we want it to be able to actually conduct the heat quite well. And the moisture content, fairly obviously. Chemical oxygen demand, to look at the amount of nutrients in the organic form that are in the urine. And then whether or not the total solids were changing how much was in there, the urine itself, and the look at mass loss and heat flow of urine with thermogravimetric analysis. At the same time, in mechanical engineering, a final year laboratory project group looked at building the actual urine evaporator for further testing, and they looked at the various concepts, selected the general idea, which is a circulating countercurrent evaporator, built the evaporator, and eventually tested it. I think they managed to do 1 or 2 tests, but then we also continued the test work during the vacation period. First of all with water, and then with a saline solution as well. And since then, we have actually done urine evaporation tests. However, we don't have all the results completed yet, so I won't be actually presenting those. But just to give you an idea of how the evaporator works, is the dot a pointer? Yeah. Okay. Oh, okay. Okay. Sorry. Yeah, it's a little bit difficult. I can only do it on one screen, but effectively we have an evaporation tank which has a shower head at the top, so the urine is actually flowing downwards over packing. We did try 2 different types of packing. First of all, pebbles, but also with standard PAL rings. And as the urine collects in the bottom, it actually flows down to a mixing tank to make sure that any solids that are maybe precipitating out will actually remain well mixed and don't end up just getting stuck in the system. Then goes down to the holding tank and then is pumped back up. Meanwhile, there's airflow coming into the bottom of the evaporation unit, and that is going countercurrent, and it's preheated air or no preheating. Sorry, I keep forgetting to use the wrong. You have such technological, wonderful things here. So for the urine itself, the stabilized urine, which had lime added, as the total solids increased, the pH was stable, so we weren't losing ammonia, so we weren't losing nitrogen or nitrogen content from the urine over time, as we increased the total solids in the urine from a very, very low amount to about 10-12% solids. The hydrolyzed urine, the pH actually dropped because of ammonia generation and ammonia loss with the actual evaporated water, but it headed towards a neutral pH over time. Electrical conductivity, as we're concentrating ionic substances, the electrical conductivity was rising in both cases as the urine evaporated or the water was removed. The water activity, in other words, the free water that's available as such, as the solids increase, the water activity does go down. However, it's still mainly water. Once we got to about 12% solids, we've still got 88% water within the urine. However, we've removed a heck of a lot of water, which is very useful. And as the water conductivity, the water is lost, the conductivity actually goes down because the total solids percentage is rising as we go along. And that's for both the stabilized and the hydrolyzed urine. So drying tests on the actual urine itself in a moisture analyzer showed that at 40 degrees, we could actually dry the urine almost completely, a small sample, within about 70 minutes. This wasn't likely to be the case in the evaporator because we're obviously dealing with a lot more urine for the amount of energy that's going to be going in. But it did show us that we could actually get a decent mass loss against time or good drying rate at 40 degrees when compared to 100 degrees, which is going to require a lot more energy. The COD values showed that if you look at the stabilized urine compared to evaporated stabilized urine, We didn't seem to be losing the organic content or breaking down the organic content. We still had a similar COD level. And the total volatile and organic solids, I'm not sure why that table's there, but that was for the initial material. So we had about, well, it was less than 1% total solids at the initial state. Oh. Okay, so the urine evaporator, here are the students with the urine evaporator and a computer showing the design of it. But the actual unit itself, in the corner over there, which is, the main tank is stainless steel, and it was supposed to be stainless steel. We found out later that some of the inlet sections weren't stainless steel, which did lead to having to put off the urine evaporation testing itself for a short amount of time because urine started coming out into the fan and it wasn't pleasant. But that wasn't their fault because that was just the way it went. So the first tests of the actual evaporator using water at 40 degrees, 30 degrees, 50 degrees, with and without airstream heating. There is an actual heating element within the evaporation unit. And with salty water, were analysed for the rate of evaporation, the efficiency, and also the specific energy consumption to evaporate 1 cubic metre of water. So in other words, kilowatt hours per metre cubed. And the initial analyses showed that the first and the third runs were the most efficient, using a minimal amount of power compared to, for example, evaporating at 50 degrees Celsius, and a specific energy consumption that was the lowest that we could achieve, which is about 1,500 kilowatt hours per cubic meter of water evaporated. So in conclusion, the physiochemical properties of the urine, the thermoconductivity, water activity, viscosity, and electrical conductivity were relatively stable with constant values and smooth variations during the majority of the evaporation process. What that would actually mean for us is that when the evaporator is being used, because we're not looking to desiccate the urine completely, we would actually have some relatively stable physical properties, which means that the evaporation rate can be maintained over the time. The urine isn't going to become too viscous, it's not going to actually start to break down, and we're not going to have a huge loss of materials, things like ammonia, if we've got stabilized urine in there. The heat consumed, similar to the latent heat of vaporization of water for the majority of the process, and the evaporation of stabilized or hydrolyzed urine was fairly similar. So we didn't seem to be degrading the organic matter. We could achieve evaporation at about 30 to 40 degrees Celsius, and since then we have actually done tests on the urine itself at 40 degrees Celsius, and so it did seem to remove a lot of the water. Went down from about 8 litres of urine to about 5 litres after, I think it was 5 hours of processing. So we can effectively concentrate urine using this evaporator. And that should do it. So thank you.
Thank you very much, John. I'd like to open the floor to discussions. Any questions for John? Prof. Bright?
If I can't answer it, Santi's here anyhow. So
I shouldn't have come to this because once I listen to a presentation, unfortunately, I always have questions. Sorry, John.
No problem.
You might not be able to answer these, but don't feel bad if you can't because I'm not too sure on your depth. You say you got samples from 2 sources. One was from as you say, a student source, I think, and then one was from a taxi rank or something.
Yeah.
Now, just in principle, did you notice a difference in the chemical composition of those 2 sources? Were they fairly consistent?
Well, the biggest difference would be the fact that the urine that we collected within the department was fresh. Okay. So we stabilized it immediately by adding lime.
Okay.
And that meant that we weren't going to get a loss of ammonia.
Okay.
However, what's coming from the taxi rank has been there potentially for a couple of days. So it's already lost, it's hydrolyzed, it's lost a lot of the ammonia, and sometimes the organics aren't looking so nice. They're beginning to oxidize, etc. So it does have different properties in the sense of small changes based upon the age of the urine more than anything else.
Yeah, no, I would have thought so. Then the next question, of course, from mechanical, we had our open day last week and I saw the apparatus. Do you have any idea what the cost of that, what did that come to in terms of material costs?
I don't know how much it was. Santi might know.
I think it's around 30,000 because that was the budget I gave them.
Last year was 100.
100,000, okay.
So, yeah, that was the 100,000 for the urine evaporator. Yeah.
Okay, then leading on for that, what is the commercial opportunity of this? You know, what would you do in terms of going out and commercializing it, and who would want it?
Well, the urine that has been evaporated can be sold commercially as a fertilizer. Unfortunately, it does require a lot of licensing, etc. So that is something that we would look to do going forward, actually increasing the size of the evaporator, obviously improving on it. That's why there was an evaporator this year as well. We're looking at improving the design and improving the actual evaporation, and then going into some kind of pilot scale and then taking it forward, because there's a lot of urine around, particularly from non-sewage sanitation units, and it can be a product that would actually be saleable. So in circular economy terms, it works.
I think we're going to cut the question there. Maybe you can just pick up Dr. Pocock afterwards. Thanks very much. Thanks, John.
Thank you.
Thanks. Okay, and this brings us to our last presentation of the day. So our presenter is going to be Yashin Paitha, talking about disrupting bound water in fecal sludge to improve water removal processes. Thank you.
Afternoon, everyone. I can understand if your heads might be gone at this point, but thanks for joining me. My name is Yashlan Patha. I'm a current master's student at the WASH R&D Center at UKZN, and today I'll be presenting on my topic on disrupting bound water in fecal sludge to improve water removal processes. So a brief content on what we will see in this presentation. I was told to just talk about myself a bit. I didn't think it'd have to be extremely technical in the brief. So the first part will be a little bit about me. And then from there, we would look at the background of the project. So this project is a continuation of a PhD topic that was previously done. So we'd look at that first. And then I would talk about what I've done so far in my project and the progress we've made before highlighting some key points and key references that have assisted me in the project. And then we'll finish with the acknowledgements. So I finished my undergrad in chemical engineering at UKZN in 2022, graduated in early 2023. And that's when Santiago messaged me and said, we have an opportunity for you to pursue your master's. And I had worked with them in undergrad during my industry project, in which I helped with the evaporators and the solar dryers. So I decided to continue my journey in education with my master's in chemical engineering, which I started in 2023. And the office specializes in WASH, which is water and sanitation hygiene, so wastewater treatment and research. So why did I choose WASH? So in undergrad, not even graduated yet, I was filled in an office with PhD and master's members, and they treated me like an equal. So there was always a sense of family in that office. And they were making some really interesting breakthroughs in the wastewater treatment field. So when I first decided to do chemical engineering, one was the money, obviously, but two was that I wanted to make a difference. And at the office, this is what they were doing. So I decided to pursue it with them, and I got the opportunity to conduct research on wastewater treatment. Then, of course, it was fully funded, so that gave me the opportunity to not have to worry about too many things going forward. And I also got to network and meet a lot of interesting people in the industry and who were able to share their knowledge and expertise with me. So as part of that, I was able to attend a few conferences. The first one was this year in June. I was able to attend WISA, and I was able to learn a lot about water and water innovation techniques in order to treat water. And according to the latest Blue Drop and Green Drop reports, the results are not very promising. So there's a lot of innovation and progress being made in the water treatment and wastewater treatment field, and this conference highlighted that. The second conference I attended, I had the privilege of attending the WasteEng conference in Japan, in which the key topic was waste valorization, which is making something valuable out of waste. And at that conference, I learned a lot about how and why we need to improve techniques in the waste management field in order to move forward with sustainable development. At this conference, I was a speaker. I presented 2 papers, the solar drying systems and the disrupting bound water topic. And I managed to win an award for UKZN and won the Best Student Award. So about the project, the previous project, Dr. Santiago and co at the Wash Center looked at a problem. The problem was that in South Africa, many of our water treatment facilities are failing. Right? Fecal sludge is a matter that's very high in moisture, and this requires a lot of large space to contain. It requires extensive pumping requirements, high transportation costs, et cetera, et cetera. On top of that, it's also high in pathogen content, which contains pathogens that are detrimental to health. So this is why it's important to reduce the moisture content in order to inactivate those pathogens. So if we look at the flocks, an example of a fecal sludge flock, the moisture content was able to be, the types of bound moisture were able to be shown in this picture. How I'd like to show it to you is in an example that I did in the presentation yesterday. If we look at a sponge, right, and we wet that sponge and we pull it out of the water, we have water that falls off, and this is the free water that is easily removable, just falls off the sponge. You then have interstitial or capillary moisture, which is within the pores of the sponge, and that would require just a bit more effort to remove. And finally, you'd have, the second to last, you'd have surface water or vicinal water, which is attached to the surface of the solid particles of the sponge through absorption. And this would require a lot more effort in order to remove. So you'd have to wring the sponge and really push it to get the water out. But finally, you have intracellular or chemically bound water, which is trapped within the cells of the flock. And this requires an extensive amount of energy to remove. So that's why it is important to improve methods to dewater sludge, because we can reduce the mass of the sludge, which therefore decreases transportation and storage costs, and it also valorizes the organics in the sludge. So the key outcomes from their research was that they were able to map the bound water proportions in fecal sludge, with previous knowledge on fecal sludge fairly limited. So from this, they were able to show that interstitial capillary moisture was found between 50 to 70%. Vicinal moisture was found between 25 to 50%, and then intracellular moisture was found below 25%. The key highlight from this was that the ideal moisture content to reduce the sludge to was between 20 to 30%. This was optimal in volume reduction and valorization. This leads to my project, which is disrupting bound water in fecal sludge to improve water removal processes. I am supervised by Dr. Jonathan Pocock and co-supervised by Dr. Santiago Septien-Strengel and Dr. Renoile Seodang. The key aim of the project was to identify methods to disrupt this bound moisture within fecal sludge and fresh feces, and convert that bound moisture into unbound moisture. To do this, we would have to determine the mechanisms themselves and then identify specific treatment methods that utilize these mechanisms. Then we would have to demonstrate and bench these treatments at lab scale and compare them against key performance indicators in dewatering, rheology, stickiness, and drying. And finally, we would benchmark these methods by a techno-economic analysis to identify which is the most viable option for the South African landscape. So we would have to convert the water that is bound from either intracellular water or vicinal water or interstitial water to unbound moisture. So in order to do this, we first started with a literature review in which I extensively reviewed articles on fecal sludge treatment to identify the bound water disruption mechanisms. And from this, we were able to find various key disruption mechanisms to convert this bound moisture to unbound moisture. We looked at various treatments, including physical, chemical, and biological treatments, so we could see how these treatments would affect the sludge. And that led us to the development of an experimental plan in which we would take these treatments that were found and run extensive tests with them to determine which was the best treatments. Okay. So from the research, we were able to find the disruption mechanisms, and the two key disruption mechanisms that we were able to identify was EPS degradation, in which the extrapolymeric substances within the sludge would be disintegrated to allow the water to be released, and cell lysis, which would lyse the cells that trap the intracellular bound water and allow the water to be released. There were various treatments, like I said. So the physical treatments we looked at were microwave treatment, sonication, freeze thawing, electrical treatment, thermal hydrolysis, and deep frying. The chemical treatments we looked at were coagulation, flocculation, acid-base treatment, advanced oxidation processes, and the biological treatments we looked at was DMSO addition and enzyme treatment. So we did a case study analysis on each of these treatments, and we compared them against performance indicators via an RAG table. And from that RAG table, we were able to choose our selected treatments, which were microwave, freeze thaw, lime treatment, and enzyme treatment. We further added mechanical shearing as a treatment, as we wanted a physical treatment to compare our results to. The variables for each treatment for the first phase of experimentation would be the literature variables we discovered, as this would give us a starting point as to what the optimum values would be for our variables. However, this would be a multi-phase project, multi-phase experimentation. So in stage 2, we would take the best treatments from that initial experiment, and we would adjust the variables to see which is the best variables for the South African context, so sludge in the South African context, because many of these research articles weren't for sludge in the South African context. And then our final stage of our project would be to hybridize the treatments. So look at how combining treatments would affect its ability to disrupt the bound water and remove lower the moisture content, or see if that is actually a better treatment option. So far in the project, all we have done is the initial project analysis, and we are still continuing with the first phase of experimentation with the results soon. But I've presented the results of the initial sample analysis for you to see. So the key points that we have for the project is that in phase 1, we were able to characterize the different moisture fractions and identify how each moisture fraction acts in each phase. And in phase 2, we were able to identify the disruption mechanisms, which would help disrupt that bound moisture and convert it into unbound moisture, which can be easily removed. Experimental work is ongoing, and we look to identify the most promising treatment for the South African context. These are some of the key references I used, which would give us the values for the variables used in experimentation. And finally, I would like to thank the WASH R&D Center. I would like to thank UMNGENI Water, and I would like to thank the WRC. Thank you. Oh, and lastly, if you have any questions or you would like to look up the WASH R&D Center, please scan the barcode and feel free to message anyone there if you have any more questions. Thank you.
Thank you very much. I'd like to open the floor to any questions or comments. Thanks.
Sorry, I just wanted to ask if you could. My name is Jonathan. I'm a master's student in chemical engineering. I just wanted to ask if you could clarify what you mean by sludge in the South African context, because you kept mentioning it. And do you have is there a difference in the type of sludge? What are the variables there that you could give?
Okay, thank you for your question, Jonathan. So when you look at the South African context of sludge, we predominantly use VIP toilets, UDDT toilets, septic tanks. And so the experimental work that I'm doing on is a mix of all those sludges. And so the composition would be different as to compare the research that I got from China or India. Their sludge would have different initial compositions, so that the experimental work and the optimum variable conditions would be slightly different.
Thank you. Any other comments or questions? Don't see anything online. If not, thank you very much for your presentation.
Thank you.
All right, this brings us to the end of a long day. It's been an exciting journey. I think we've covered a huge range of fields. And I guess even though I'm aware of all these projects, I've learned a huge amount just from the presentations. So I think maybe we should just, again, show our appreciation to all the presenters. So thank you very much. I know a lot of preparation. I think we're more or less back on time. We're going to make the closing ceremony or the prize-giving ceremony, so I'm not too concerned about that. Are there any burning questions, any comments anybody wants to make before we start wrapping up for the day? I know we did curtail the question times to try and keep on track, but we've got a couple of minutes if anybody wants to make any comments, just general comments about the presentations or any specific questions. Happy to take those now, but I'm not seeing anything. If not, maybe we should start wrapping up. I think maybe can I come to you at the end? That okay? Yeah. I think just from my personal perspective, I'd really like to thank UMNGENI, UTHUKELA Water for their support. It's obviously pays my salary, so I'm very happy about that, and it saves Prof. Bright some money as well, so he's also happy about that. Okay. I think and I guess, I mean, as I said at the beginning, one of the intentions of this symposium was to try and improve the collaboration between the two institutions, UKZN and UMNGENI UTHUKELA Water. And so I was really, really pleased to see so many people from UMNGENI UTHUKELA Water here. So really appreciate that, certainly compared to our previous symposiums, and this is our third one that we've done. So we really appreciate you making the time to join the session and to interact, to see what we're doing, to see some of the faces that we might have just seen on Zoom or read about. I think that's really good. And as I said, I think this is such a beautiful opportunity to work more closely together. So we need to connect between researchers and industry leaders. Let's look at what the issues are, and let's see if we can put our heads together to try and resolve them and come up with innovative solutions. I think that's really challenging all of us to do that. So I'd like to thank you again from my personal thanks to UMNGENI Water for that. I'd also then just like to hand over to Prof. Glenn Bright, who's the Dean and Head of School of Engineering. Thanks, Jeff.
Yeah, thanks, colleagues. For me, thank you. I just want to do a vote of thanks for the support of UMNGENI Water for not only this session, but for the conference. So if we could just give UMNGENI Water a round of applause, please. Also, thank you to the UMNGENI participants who came and the support. Also, of course, Professor Smithers is our UMNGENI chair. Yeah, and thanks for reminding me I don't have to pay your salary. It does help the budget. But yeah, thanks to UMNGENI Water. They don't only help in terms of supporting our staff, but they help in terms of supporting our research for many years now. So once again, thanks to them. And also thanks to all the people in the audience for coming along, your support, doing presentations. I found it very interesting. Keep working hard on them. It's a great initiative, this PRIS. which is done by Sally and her wonderful team. There's prize giving coming up in about 10-15 minutes. So once we're done from here, please all go upstairs and I'll see you up there. Thanks again from the School of Engineering, the Dean of Engineering.
Thanks, Glenn. Dr. Deborah, do you want to close the session for us?
Thanks, Jeff. I'm not really closing the session. Dr. Ngube is going to do that part. But just my overall observations and comments. As you would have picked up from my opening remarks, that the research that's being undertaken through the chair has to be as impactful to the organization as it can ever be. And we've actually witnessed that today. Hence, we keep on probing, where we are identifying some gaps. So like, can we close off this project with this part for implementation and so forth? So it's not meant to sort of like criticize negatively what's being done, but just to enhance it for applicability within the organization. But overall, we've witnessed that. And thank you very much for driving this, because we don't have the capabilities internally as UMNGENI UTHUKELA Water, and you are our driving force in any case. So let's continue this collaboration, continue doing this great work. We really appreciate it, and it's just a matter of, from our side, to rope in all these project managers to be heavily involved to guide the expectations out of these initiatives that you are undertaking. So it's great work indeed. Jeff, you may have had a comment from me yesterday which sort of like deterred you in a way, that from the session that I was judging, there was minimal novelty that I picked up for some of the presentations. But in here, I actually identified that there's that strength therein. So it's really appreciated that you considering innovation in the projects that you are doing for UMNGENI UTHUKELA Water. So Jeff, you can be rest assured that we are witnessing that, and we have confidence in that. Yes, we may have a need to tighten here and there, close some gaps, but we are extremely pleased with the initiatives that you're driving for us. Thank you so much.
Thank you very much, Dr. Depper. And can I hand the mic over? Sorry, while you're coming up, we just handed out an evaluation form for the session. So please, if you could evaluate it, it's part of the X accreditation. So we need to have that. So nobody's allowed to leave until you've completed the evaluation form. I've also got the registration forms up here. If you haven't signed it, please make sure you sign it before you leave as well. Thank you.
Thanks, Jeff. Thank you, ladies and gentlemen. First of all, I would like you guys to give yourself a round of applause for staying with us for this long. As our executive have mentioned, that what is more keen is that we are looking for as an organization is operational excellence, innovation part, and then partnership. The innovation part, I would like us to actually understand the fact that the reason why the company is pushing us on the innovation part is because when they ask us the return on investment, we must be in a position of explaining the collaboration. We must be in a position of saying, going forward, this type of the research that we are looking at. Because this partnership, as you all are aware, that we are in the fourth industrial revolution, right? But if you look at most of the research we did today, you will say that we were sort of in the second and third industrial revolution, not exactly in the fourth industrial revolution. But it will be nicer going forward. We focus much on the fourth industrial revolution. Coming back to our presenter, let me start with most of the guys who were on hydrology, and especially those who did the modeling part. Your presentation was good. It just lacked a link between the challenge and the person who needs the solution. Let me make an example. Let's say somebody develop a modeling for flood. Let's take flood for an example. And I'm using UMNGENI River as an example, and our water treatment is at UMNGENI River. So when somebody do a modeling or somebody installs some system upstream, and then that modeling or that system must actually notify me in the plant and say there is a storm upstream. In an hours later, my extraction part will then be flooded with pollution because of the storm, you understand? Then as an operator should be making those changes to actually mitigate the operational challenges. So you understand? So when you do this modeling and all of that, think about how you're going to apply it in the workplace and how the operator that needs that modeling is going to utilize that. So we understand that. Most of the other presentation, I will be lying to you if I said we were not pleased. We were extremely pleased, and we are looking forward for, I'm now currently looking forward for the next 2025 function similar to this one, because I'm of a view that next time there will be a clear problem statement, clear potential solution, and how this solution being applied to the problem. So you understand? And then also take into consideration also, we still look at the economical aspect or the financial aspect to actually see. Because when I was asking, that the activated charcoal project, when I was asking, is in a field part or is still in a lab scale, it's because in my mind, I was like, this is a good project. We have to implement it. But the fact that it needed pyrolysis that it heats at 90 degrees, that means it's going to be too expensive to implement it. But if the owner of a project have come in and said, look, the charcoal is cheaper, we get it for free, we go and dig a charcoal and then implement it. We were going to say, oh, let's go for it and test it in one of our plant. You understand? We have over 40 water and wastewater treatment plant, and all over 40 are too expensive to run and are giving us problem. And we are not getting any good income on a wastewater treatment. We're just managing so that we keep our environment. And we need solution in all of those areas. Without wasting any time, because some of us are hungry and some of us are driving, we're going to be driving very far. I will also want to say, give yourself a round of applause, and thank you very much for attending this session. Bye.
Thank you so much. On that note.
Yeah, TK, you perhaps forgot about this one. As you would know, this is the very first of these. And it would not have happened without our brand and marketing department. Thank you very much, Knox. Thank you very much, Max. We really, really appreciate it. And had it not been for you, this beautiful setup in here, you went all out for us. We really, really appreciate it. Thank you so much.
Good. On that note, I'd like to close the session, and I think we're all welcome to go and join the prize giving session, which is upstairs in the Sapphire room, I think it's called.